Sorry to interrupt the mic. You are muted.
Okay, we're almost ready to go. I'm hoping everyone can hear me, and we're going to start sharing my slides very soon and get the event underway. So thank you everyone for joining. Brilliant. Okay, so welcome, especially to our third Global Drone Security Network. It has been a very interesting last year, and to be honest, we weren't sure if we were going to be running another one of these, but last year we did manage to run two, all things considered, and we'd like to thank a special welcome to some of our partners, the Association of Aerospace Industries Singapore, which helped really kind of perpetuate this event forward and gather up, some attendees and things like that. So we're really excited to have you. And of course, we want to welcome all of our guests, our honored speakers, which we really appreciate the time and effort given the COVID situation. And of course, just a props to my own Dronesec team as well for their time and effort in putting this together. So throughout the show, you'll have various resources from different places, but I will provide you with some on the right. If you want to continue the discussion far after the event has ended, you'll be able to join the Dronesec Slack group where you can chat with people. Otherwise, you'll look in the speaker slides. They'll be attached to the description of the YouTube link within a little bit of after the people are started speaking. So what is the Global Drone Security Network, especially for those who haven't necessarily joined in the past? Well, when we first started it, we realized that there really was a space to be able to have a source of authority and standards for drone security around the world. We wanted to ensure that our mission was safe and secure drone operations to enable innovation and prevent restrictions on the industry. And of course, in terms of the speakers, you have to realize that many of them are drone flying hobbyists or commercialists themselves. They use drones at home, they use them in their operations, and they want drones to innovate and go forward rather than be against them. So even though we are focused on security and we have some crazy stories and scenarios of drones doing very bad things by very bad people, and the systems that are there to defend against them, we are all very much for safe and secure drone operations. Now, some key things that we always try to keep independent and agnostic about the GDSN is that no one paid to speak here, and we didn't pay anyone to come and speak. We hand select everyone who applies, and we appreciate those who do because we can find out the different snippets of information from different areas. There are no sponsors or commercial deals. Everything is run from Dronesec, and of course, everything is live, so you can ask some questions which maybe the speakers might not be prepared for and ready for transparent answers. Now, of course, in terms of the GDSN, we're facing many different threats to both friendly UAS operations, but also to the people and facilities from malicious drones that we're trying to counter. So in order to try and prevent that and counter these threats, we need a highly coordinated response from global organizations and law enforcement. So in order to do this, we've seen a lot of scrutiny for data security and privacy from manufacturers. We've seen a lot of counter-drone systems being evaluated for their effectiveness. And of course, we want to get those experts in the field to come and collaborate and solve problems like these. So that's really the first thing that we started out doing when we were looking for the different speakers that would make up this GDSN event. You'll find each of them touch on an important point and give you that technical information you need to try and make some of those decisions or solve some problems in this space. And for some of them, we welcome them back for a second time, which we really appreciate. Let me just double check people can hear me okay. I will check this. So let's go here. Now, you can hear me okay? 601. All right, I'll just reshare that in case I saw a comment saying it wasn't coming up, but let's just trust it was all good, and I'll reshare my screen. Bear with me one moment. And here we go. I should have it back on again. All right. Thanks to whoever that was that said the comment as well. So, as we were saying, we have people coming across from different areas of the world. We are doing a train across the globe again, like last time, but this time the key is that we've split it into 2 days. We wanted it to be able to be ingestible on 2 separate sections so that we would be able to have people attend compared to last time. So we're starting off in Australia, we're traveling through Singapore, coming across Israel and South Africa, and then we're going through France, the UK, and the US. Now, in terms of the agenda, day 1 is going to see Ong Jinju at 6 p.m. Melbourne, Australia time. We then have following at 7 p.m. with Antoine Menini, and at 8 p.m. we have Victor Villard, followed by Kim James, finishing off the night at 9 p.m. And on day 2, I'll go through the details, but we have Gabriel Bendheim at 9 p.m. So it's starting a few hours later than it is tonight. Ilker Garrick at 11, and David to finish off with the keynote at midnight Australian Melbourne time. So just some quick housekeeping. This is a discussion and Q&A talk. So we will have people presenting, and then you will have a space to be able to ask them questions. You can do so on the comments on the YouTube link there, and our moderators will see those and provide them to me. I will be your MC and host, so I can ask those back to the speaker. And of course, if you want to find anything like the schedule, the presenter slides, or the code of conduct, which we implore you to read, you can see that in our show more area of the description. Of course, those are your team members running the event towards the bottom right, and we're always happy to help you. So who is Dronesec and why are we running this? Well, Dronesec, we are a cyber security and threat intelligence firm for drones. We want to provide situational awareness and early warning to facilities and critical infrastructure against malicious drones, but we're also there to protect friendly drones and drone operations against attack, data security, and privacy risks. And I'll just cover that off in case you're wondering why we're running the event and how it all works. But you may know us from some of the weekly UAS threat intel reports that we put out to try and keep people across the information about how many threats are out there, what are the unique threats that we're seeing, and how it all works. And in terms of the event being run, how did we manage to do it? Well, the event is powered by Dronesec Notify. So that's our UAS threat intel platform. Tracks incidents, notifies you about them, and provides analysis about the different threat actors out there. And in fact, some of the speakers themselves use the platform and are on it as we speak. Now, one thing more that we want to mention is a special thank you to all the attendees for coming. Some of you had asked the question of whether the Dronesec certificate or the training would be available at a discounted rate, and we are happy to provide that with a discount code. So if you are looking towards that or to join some of the students that we've had from other organizations, feel free to use that code when going to purchase some of that training. Now, I've spoken for far too long because we've got too many great speakers to get onto, and we're going to get Ong Jinju to prep in a minute to be able to go on, and I will welcome him in. But first of all, again, a thank you to the team for putting this together. We thank you for the speakers for being available and wanting to provide their knowledge and contribute to the industry. And a special thanks to Kim James, Victor Villard, and David Kovar, and CerbAir, the company, for being follow-up speaker presenters for the second time, which we really appreciate. So any questions you might have during the event, feel free to email us at info@dronesec.com. And again, a special thank you to Aerospace Industries Singapore for helping us out with running this event. Last thing I just ask you to do is at the end of the event, probably after the 2 days, but if you only attend 1 day, that's fine. Hit that feedback link because it means a lot to us and it means we can improve the event for the next time that we have this. So thank you very much. And I'm going to start the process of handing over to Ong Jinju, and I'll get that ready for you in a moment.
Hello. You guys hear me? Okay, is that good? Hello. All right, cool. I think we're online.
And it's great to have you. I might need your mic to be on, and I'll just do a quick test.
Great. Can you hear me?
I can hear you.
Okay.
Brilliant. I will let you take it away and share your slides, but thank you so much for joining us. We appreciate your time. I'll be collecting some questions, and after you've finished your talk, I'll rejoin to ask some of those. But thanks again, and feel free to share your slides and take it away.
All right. Thank you, and thanks, Mike, and thank you everybody for dialing in. This will be the first time I'm speaking at Dronesec, and a lot of our sharing we're going to do today is based on our experience in Singapore, in Southeast Asia, and hope it's going to be useful for everybody's sharing. So I'm going to focus a lot about internet-connected drones because that's something that's kind of close to my heart, and we have been trying to push out internet as the kind of the backbone for drones. But before I start, maybe I give a quick introduction about our company. Garuda Robotics, we are an AEO company. We're based in Singapore. We have presence in Malaysia, but we also fly pretty much everywhere in Southeast Asia and South Asia as well. Our business is organized into three different segments, right? So we are on one side, on the left side, you have the fly safe product teams who look at BB loss as a very important capability, and we were active in doing inspections, deliveries. We build command centers, and we also organize a lot of training and compliance consultancy for customers. In the middle, you have our GeoSmart team, who is very much focused on the artificial intelligence side of things. We have built applications from facilities management, smart cities, and plantations, and so on. And we use geospatial technology as well as AI, machine learning, computer vision in order to get our drone data analyzed. And on the right, we have a business around security, specifically around homeland security, to help airspace management for the regulators, as well as cybersecurity. And this is kind of the focus of today's topic. And in general, other kind of homeland security use cases like delivering an AED drone to a cardiac arrest station. Now, this slide is just to kind of motivate why we talk about internet-connected drones. It's in my opinion, it's an inevitable outcome, right? So the fact that the drone industry today it's so vibrant and there's so many players, it's also partially driven from 10 years ago. We started adopting mobile-based technologies, right? We have GPS becoming so cheap, and all these iNews, MEMS chips, and all this becoming so affordable that people could just slap it onto a drone and start flying, and you end up with many companies being built around these use cases. Why not go all the way, right? So to put a SIM card on a drone, basically, is what we say. So these are numbers I took from GSNA, and apologize for those who I borrowed quite a bit of pictures from different slides and studies. Right, so GSNA published a study I think just last year, right? And these are some of the numbers they said, right? So a lot of drones, specifically they estimate to be 6.5 million drones by 2025 will be connected to the internet in real time, right? And a lot of it will going to be in logistics and transportation, public sector, and so on. The ones I dotted up is the ones that we play, and we have a lot more information about, and the products that we have kind of built around these internet-connected drones. And this is not kind of a first day, right? I mean, I guess we have been trying to do this for the last 5 years, and these are some of the examples of ourselves as well as some of our partner companies in Singapore who have been flying some internet-connected use cases, right? An example will be we'll be working into a hospital called Part1 Pantai to try to do like delivery of blood samples. Another example will be the maritime logistics, which I think last week we did a bit of a launch of a maritime drone estate with a couple of other companies who are saying that we're going to use this maritime drone estate to do shorter ship deliveries. At the same time, we have the first responder side, right? We created a system called Garuda Responder, which is to deliver AEDs, but also other kind of emergency medical devices. Again, controlled via the internet, right? Or for incident response, we have a product together with a partner, Flight Dynamics, to do perimeter patrols as well as respond to incidents like fire and so on, coverage. During the last year's lockdown period, we've been helping government customers to do safe distancing by connecting, again, drones directly to a cloud and running computer vision algorithms to find where are people crowding up to prevent all the virus from spreading and so on. And last but not least, we've been working with MNOs like Singtel, where we can try to do something called UAV hardware tracker to track drones as they fly to give the regulators a full vision of the airspace, right? So this is basically something related to the upcoming topic of remote ID. So how do our products kind of look like? Just to give you a sense of it, we've been putting cellular technologies onto all three parts, right? So on the left, you have the tracker, and this is kind of the current version of it. We're still miniaturizing it at 60 grams. It is a self-inclusive, it's complete in itself, right? So it has its own IMU, GPS, 4G connection, SIM card, and so on. And can transmit basically securely, right, the position of the drone, whichever drone you kind of stick on, right, to a regulator or to a UTN provider and so on, right? The middle picture you saw there is just an onboard computer. I think many people are building these such onboard computers. Ours will be building it with two modems, one 4G, one 5G, because there's quite a bit of 5G projects being rolled out this year. We are trying to get into the market to help customers understand how to connect via 5G, and as well as internet connected drones itself. That means out of the box, you kind of buy drones from us that already have this cellular connectivity. So the talk for today, I'm going to go from the left to the right. So we're going to focus a lot first on the hardware tracker that you see here, which is turns out to be quite contentious. I was surprised, right? So when we started doing this tracker about 3-4 years ago, when we look at it, it's like, it's no brainer, right? We should just be able to just put a tracker and put a SIM card and be done with it. Well, it turns out that there's a large community around the world talking about this whole idea of a remote ID, right? Essentially, what we all want eventually, right, is to have an equivalent of a car plate. Every country in the world, every car has a car plate, right, of some sort. You don't know who drives the car, you don't know where the car is going, but when the car does something that's not supposed to do, you have a car plate number, you can call the police and say that car just banged into me and the ID is so and so, right? So fundamental to any kind of management of airspace, it's basically the ability to identify any objects, right? So this was taken from one of the latest versions of the documents, the picture, I mean, right? That basically stipulates that these are the two possibilities for us to actually have a car plate, the equivalent of digital license plates for drones. Now, you can't have the same equivalent physical plate because the drones are so far high in the sky, you can't really see it with your eyes, right? And we don't carry binoculars around. So we tend to use some form of a remote radio frequency, right? So you have the first case where you have what we call the broadcast remote ID or broadcast UAS, where you will use technologies that's kind of common to all our mobile phones today. Bluetooth, Wi-Fi, there's this technology called Wi-Fi aware, which all the devices like your Apple, your Android, and so on will be able to just connect to it and receive certain information about the drone. What is its latitude, longitude, an ID of the drone, what is velocity, and potentially even like whether it's in an emergency mode, it's actually trying to come down because it's not doing well, and so on, right? And then you can kind of verify whether this drone is really saying what it's supposed to say, because there might be attempts to spoof that information. On the middle side, there's this more complex architecture, right, which is this network remote ID or net RID, they call it, right, where either the drone or the GCS is the ground control station, right, the app or the transmitter that controls the drone for the pilot that's standing on the ground, would share that information via the internet, right? So maybe via the mobile phone's internet, or directly on the drone itself. You kind of put a SIM card there, right? To the cloud, some provider, right? In this case, the Envision provider is what we call a UAS service supplier, USS, right? And through some very complex and very how do I put it? Very secure, right, way of passing the information. That information eventually still pass on to the user of the mobile app on the right, right? And of course, there's a third kind which we won't focus much today. Is basically to say that there could be also other ways to know who is flying if you ring fence a place like the university or a school where the students are only the ones in the school flying. So it's fine. You can just let them go and don't have to force them to build a broadcast or a network device on it. On the right, you have basically the public, the law enforcement people. A lot of people are interested about who is doing what with a drone, right? So everybody wants to get the telemetry. Partially also because I think from my perspective, right? I mean, I grew up with this website called Flight Radar 24, and I really like to just go to the website and watch planes fly, right? Because planes they do broadcast their location using a technology called ADS-B, Automated Dependent Service Broadcast, which allows us to see where every drone is and can kind of follow where my parents are flying to Singapore. I can follow the plane and know whether they're arriving. So I thought it would be a very normal thing again, right? That everybody just share what they're doing. But it turns out that that's not the truth, right? A lot of people are actually not comfortable at all sharing where they are, what they're doing to people they don't know, right? Which brings me to this kind of a spectrum, right? So during the whole proposal for remote ID, there was strong proponents on the left, which is for the broadcast remote ID, and there are strong proponents on the right, which is the network remote ID, right? So if you look at the left, which is the broadcast only side, and we'll dive in a bit later, right? So this is the current latest status from FAA, right? So FAA, by the beginning of this year, finalized a ruling around this, and together with ASTM, they have this standard called F3411-19, where it basically just says, forget the network flight, just do the broadcast one, right? So you just have either Wi-Fi broadcast, Bluetooth broadcast, either your drone broadcast or your you have an attached UAV hardware tracker that you broadcast onto it. Now, there's a lot of pros to this, right? It's cheap, it's independent. You don't have to like rely on a subscription of some sort. There's no single point of failure and so on. And we'll dive into the pros and cons in the next few slides. And generally, the cybersecurity risk is low, right? That means that if you're flying in, say, Arizona, right, the guy in New York won't see you, right, because your broadcast is not going to go so far. But at the same time, from a regulator standpoint, you don't have a full airspace map, right? Or if you are just like your local airspace manager, you don't know who is doing what still until you are in the same vicinity within 100 meters of the drone, then you can get the RF information, right? On the right, you have the network-only guys, right? So those people were saying that, okay, use the internet, but the internet is a dangerous place. We all know that, right? So mainly you have to pair it with some sort of VPN or some central control, right? The hope is that there's some benevolent dictator who would take all your telemetry data and not do anything bad with it, right? You have basically then the full airspace information all coming through the cellular network. And you can do a lot of additional things, like you can deconflict, right? The use of airspace, like you have permits for this airspace, you get to go first, and the other guy have to wait, and so on. So this is kind of the basis of traffic management in the future when the airspace become more dense, when all our food is delivered by drones and parcels and e-commerce and so on, right? The cons, of course, is that if this information starts flowing over the internet, it basically inherits every single risk profile of the internet, cybersecurity risk, right? So you have to kind of design it properly. In the EU, for example, they say that broadcast is going to be mandatory, but network is optional, because I think without network RID, you can't do things like beyond visual line of sight operations and some of the advanced UTM use cases. So let's take a look, since this talk is more about cybersecurity, let's take a look at what the Americans say, because I think they were really, really against this whole network idea. So this is a picture I took from FAA's website, right? So this is the final decision, right, from the government. You can basically fly RID on the drone or RID on the broadcast module, or go to an area where you don't need RID, but FAA recognize that that area is actually a FRIA, right? They recognize the ID area, so you don't have to fly with the RID. But if you look on the right, there's this route. I mean, FAA did a good thing, like they published literally everyone's feedback, right? And when I read that document, I was surprised. It's like what, 20, 30 pages of people just saying no, and these are things they brought up, right? What if there's a distributed denial service attack on the R&D USS? So basically the servers that aggregates your telemetry, right? And once the data goes there, then it's I mean, you can say that it's secure and so on, but the data is kind of owned by RID, right? By the USS, right? So this is very much driven by people's fear today. Like a lot of data is aggregating with a few big tech companies like Google, Amazon, and so on. And would that same situation happen in the drone world, where all the telemetry actually goes to a few USS companies, right? And also bigger countries like I mean, say US, right? There's many places with just no coverage, and there's many little drones with actually some form of a network coverage device, right? So it's expensive to put in place, and if once you connect it to the internet, potentially the information might also go into some adversarial country, right? There is potential hacking or spoofing and so on, right? So you can read the rest of it. And in general, the end of it, I think the one thing that kind of make or break it is that just doing this across a large country like US is just 5 times more expensive to ensure that every single part of the country has cellular networks and every drone has cellular connectivity, right? Now, when I read through this, I felt that, look, those are all reasonable requirements, and I think that as a large country and a large place with deserts and large sorts of forests, it makes sense that broadcast would be the de facto way that you kind of do remote ID. Where even as the central FAA would not have the full airspace picture. However, as a company, as we develop these technologies, we also relooked at our own situation, right? And we also relooked at where the entire drone industry is going forward. We felt that without network RID, you can't enable more advanced use cases. So one simple example would be just to look at all the beyond visual line of sight use cases, right? To do drone delivery, to do surveillance, right? To be able to know where your drone is all the time, your drone is going to be connected by something, right? So you need basically some network. It could be cellular, it could be satellite, it could be anything else, right? But basically, if you cannot stay in control of the aircraft at all times, you cannot enable BVLOS. And the fact that you are connected means that the identifier or whatever you are doing is already coming back through some connectivity, right? The other issue we find that is that if you look at the broadcast specifications that eventually got selected, it was not some special aviation band. It was just your Wi-Fi. It was just your Bluetooth. All of them, they operate at the ISM bands of 2.4 gigahertz, which is very, very crowded, and there's a lot of interference. So if you live in Singapore, to our international friends, you will, like when I turn on my laptop, the list of access points available is in the hundreds. It's just that many access points and that many different devices trying to connect and try to fight for that Wi-Fi range. That sometimes I feel that if you're going to implement this broadcast RID in, again, another crowded city like Singapore, it's going to be some issues when you reach a certain amount of density. The third point was interesting because I was having conversations with a number of people in the industry in Singapore, and one of the points that was brought up was not every drone wants to tell you where they are because they are doing something important or secret. So if a police drone is trying to silently come around you or do some surveillance, they are not going to be broadcasting the RID, but they would definitely be happy to share that network RID with, say, for example, a national level UTM system, right, which is also controlled by, again, for potentially the military or the aviation regulator, right? So if you have only half the people or most of the people sharing your telemetry information and some don't, you still don't have the full airspace, you still cannot do the deconflict. And last but not least, we actually felt that there's a lot of work that needs to be done in the standards currently to address all the cybersecurity concerns around the protocol, right? So which brings me to the next slide. I went around to prepare for this talk. I went around to look for who has been kind of the proponents, right, of network RID, and what are the major things that they think about when we talk about network, right? So I found a few. Again, GSMA published another nice document that responds to the ASTM F341 document, which I picked some of the pictures from. But I think that the concepts are pretty similar, right? So there's a concept of you really want to preserve the operations privacy so that although you see a drone that's flying via your app or something, you shouldn't know what the drone is doing, right? All you need to know is that there's an ID. If anything, you have a complaint, you have some recourse, basically. I have to say that there's a drone outside my house and it is ID 123. You call the police knows who ID 123 is. They're going to find the pilot and get the pilot to stop being a peeping Tom or something, right? So that kind of ops privacy is important to be confidential, but at the same time allows for the ID to be easily read by anybody. The second part is basically that a lot of comms channel encryption is pretty straightforward. I think it's kind of sad that like ADS-B protocol, for example, is not encrypted. But most of the internet-based communication should be encrypted by now, right? So most browsers ignore HTTP by now. You have to have HTTPS. We all use TLS and so on. And on top of that, because if you tag yourself to the cellular network, right, the cellular industry also comes with something called the IMEI, right? So International Mobile Equipment Identifier, which is another identifier which you can use to identify the aircraft. So if you pair it well, and also the SIM card itself also has an identifier, ICCID, which if you pair it well with the system, if you design it right, you can use that as a very good way to identify and authenticate that is indeed that transmitter of some sort that's providing the information. And thirdly is this important other part, which is for transmission to happen, you have the mass market side, right? You need the infrastructure to support the entire country, right? Again, that's why the proponents for bigger countries would say that, I don't have coverage. In the case of Singapore, we have pretty much every single corner covered, right? So, and there's a committee around the world called 3GPP that's setting standards. So there's going to be a lot of devices that you can slap on the drone, which is affordable because of the massive scale that the cellular network can get to, right? And looking at existing aviation technologies like ADS-B and all this, it's just a no-go. The way it's designed is going to be flooding basically the entire frequency, and we won't be able to handle every drone having an ADS-B out transmitter. But that said, given all these design principles, there's still a lot of questions that need to be addressed. This slide just gives you a framework of how to think about these are the challenges. Again, using the existing framework of using multiple UTM service providers. Right. So, for example, if there's it's a pilot one who flies drones ID1 connected through some mobile network and from the operating center, and you connect it to some UTM service one, and so on for node two, right? So, what exact information then do you need to exchange? Do you need to just exchange the ID, or you need to exchange the ID and the location, or the ID and the location and the velocity? Like, how much information do you actually have to share in order to know what the other guy is doing? Again, let's connect that back to the land transport, right? You can see a car, you know how fast the car is going, right? Just look at it, right? And the car is going way too fast. You look at the car plate and call the police and say, this car is speeding, okay? So pretty straightforward, but how do you do it in the drone world? And let's say the drone ID1 and drone ID2 is about to collide, right? Who decides who to give way, right? It's not so easy in the sky to say, okay, keep left, right? I mean, you can, right? Or keep right, right? Or depending which part of the world you are at. But somebody has to give, right? Somebody's going to go on, the other one's going to have to wait, and so on, right? Who is the decision maker ultimately if there's multiple UTM service providers? And there's also these two things. The mobile network is actually sitting in the middle, right? Are we just treating mobile networks as dumb pipes, or is there something else that we can do in the mobile network that can enable the privacy, confidentiality, and integrity of the drone data? What if it's a hacker who connects to the mobile network to provide spoof data, right? And last but not least is, given UTM service provider 1 and 2, how about law enforcement, right? Would they then send the information to the law enforcement? Or would the law enforcement people also run their own UTM? And how do they know who is telling the truth? What if the UTM themselves are compromised, right? So we don't have an answer to every question here. What we can share is that in the product that we build and moving forward, and with our partnership with some of the mobile network operators, we actually propose that all this remote ID, if you're going to do the net-based remote ID, it should be done through a private APN, which is basically a network that behaves like you can't just connect to any. It's basically to have a private set of SIM cards basically that will allow the drone to connect to the cloud, and essentially it kind of forms a VPN tunnel to the regulator as well as the operation center, whoever has the authority to look at the data, right? I won't go into the details of this because it goes into the mobile side of things and goes very detailed, but I'm happy to answer questions after this, right? So the product that we work closely with our partner in Singapore, Singtel, is this thing called IoT Connect Plus, which you all can take a look if you're interested. So that is the first part, which is the UAV hardware tracker. Now, if you look at what about the rest of it, right? We also have the internet connected drones itself, right? Remote ID is one that's kind of a touchy topic because it applies to everybody, but you don't have to fly internet-connected drones. We have internet-connected drones in our offering, and what we do is that we allow public VPN, right? So basically, in this case, we don't do private APN because it might be too expensive, but if you still want to say, I want to have my drone stream 4G, over 4G or 5G, stream video, right? And so on, we do have solutions, and all our solutions are taking cybersecurity seriously, right? Because it's important that the drones that are being flown send information back securely, and especially if the drone also receives commands from the drone operation center, that the commands are really authenticated to the pilot and not any random person who would then hijack the drone to fly somewhere else, right? So this is the basic architecture that's all connected by VPN. There is not the UTM is kind of out of scope for this particular product, but we can be easily integrated. There's also use cases where we push some of our software, especially the parts that requires a lot of GPU, into the mobile edge. There's something that's kind of upcoming called mobile edge computing, where the mobile network operator also wants to run like a tiny data center at the bottom of their telco towers, which is much closer to the drone to enable advanced use cases to do computer vision processing, field safe navigation, and storm control, and so on. Right. So to give you a sense of how it looks like, this is my office. You can see like it's basically a combination of UTM system on top, as well as the pilot console where they can see the live streaming of the video, the map, where are the drones flying, whether the nearby other drones flying, as well as nice video streaming that comes back into the drone operation center, right? And there are many use cases there. Now, once the data comes back to the operation center, you also have this thing, right? Because the data now starts flowing back from the devices, which you saw on the left, right, up to the the ground control stations, whether it's the app version on the ground or the command center version in the room. And then it goes up again. It goes to the cloud, it goes to fleet management systems, the different UTMs, and UTMs then send information further upstream to maybe some national FIMs or air traffic management systems. While ourselves, when we build the enterprise stuff, we have to integrate with other ERP systems, GIS systems, and so on. So the surface area for attack for a UAS in a network connected environment is actually pretty large, right? So, but the only good part is that once you come to this side of the world, it becomes familiar ground, right? So it's a typical cybersecurity standards that need to apply, right? Make sure that you harden all your interfaces, make sure you don't open ports that you're not supposed to open, and so on, right? So there's a lot of collaboration here because on the left you have these devices that's actually flying out there in the sky, and something goes wrong, it falls the sky, is a mission critical, and it's a catastrophe, right? On the right side, you have the systems that traditionally, yes, use 4 nines, but sometimes the regulators ask for more nines than 4 nines. So in the case of Singapore's case, where if you're going to do beyond mission line of sight flights, for example, once you go into the medium risk and a high risk case, the design, right, of the entire UAS, not just the drone itself, needs to be able to handle what we call 1 times 10 to the power negative 6 per flight hour what do you call that? Safety objective. The probability of a catastrophic event should be much lower than that. So this becomes super hard to design, but at the same time, it is definitely the level that we need to go towards if you're going to enable beyond mission line of sight operations. And so to generalize that, basically all the non-flying systems that's related to the flying system as a whole, right? The aircraft as well as all the other information systems in the cloud, you need to be able to specify the reliability and availability probabilities very well. And on the flip side, the regulators should also be very clear about when is it good enough, because it's definitely much higher requirement than your typical, say, websites, but how much higher? Do we need to beat the banking level or even higher, and so on? There's a lot more to go into. There's another few examples of things that we go through and think through every day. For example, risk assessment, cybersecurity framework, incident response. What else are there that's currently being very well specified in the aviation world, but the moment you plug in the internet, right, you have to also put in all the best practices of internet into the same aviation regulation, because the aviation regulation governs the whole thing as a UAS, unmanned aviation aircraft system, rather than just unmanned aircraft vehicle, right? So SORA is one example. It's a pretty well adopted risk assessment framework for drones, and we are trying to understand and unpack it right now and kind of figure out how that our cybersecurity framework kind of fits inside our risk assessment for SORA. So the last part, I mean, I just kind of point out where the direction of where all this is going. And again, this is kind of a very Singapore experience, right? So in Singapore, CAS, the Civil Aviation Authority of Singapore, is very forthcoming in saying that, yes, we want to look at BB-loss, but you guys have to really tell me how to keep the safety of the airspace, right? So many partners, friends, competition, and so on. We all have been creating different kinds of solutions and demonstrations. This is a good picture that I think the NTU Air Traffic Management Research Institute published years back. And I don't think we have come to a final conclusion yet, but I think it's very important that we keep that open discussion on how to keep this airspace safe. Another point to kind of bring out is more towards what we are doing currently, which is we are a manufacturer of the hardware tracker, and we also have minimum software that kind of can show you where the tracks of the drones are. But we are also looking for what next on this, right? Because if the ASTM side only wants broadcast, which we can do, right? Where is the network side of the remote ID going to go towards? We are hoping that at some point there will be some acceptance on the network remote ID, especially in the crowded areas and places with good cellular connectivity. And once we have those network RID in place, we can start talking about higher order stuff, right? So an example will be, how can we work closer with law enforcement agencies rather than have them just specify what is good and what is bad, right? To actually go down and try it out, right? A different kind of frameworks on how we can deconflict. Maybe there's a emergency ambulance drone flying in the future. Maybe you have an air taxi that's actually ferrying you to the hospital. How can that deconflict with just your drone doing inspection and deconflict with the drones who's just flying maybe for fun, right? For recreation and so on. So those are also very important topics, and cybersecurity will have to factor into that. And last but not least, is just kind of to again thank the Privacy and Dronesec for inviting me here. And I think the work that they're doing is important, which is whatever things you plan out, you have to try it, you have to audit it, you have to rehearse it. They provide this red teaming as well, which I thought was really fantastic, where they will pretend to be the adversary, and you can see whether your cybersecurity standards actually meet the level of protection you needed. And I think that's all I have for my presentation. Hope that was useful, and if there's any questions, I'm happy to answer them right now.
Yeah, terrific, Jinju. Thank you for that. And we do have a few comments and questions that we've had from various places, so I'm happy to go through that. So I might start off with this one here, and it basically says, from a privacy standpoint, if you've got a vehicle number plate, others can't find out who you are if they're public, only law enforcement. Is this the exact same concept, or does it give counter-drone and public the ability to see who you are?
Right. So I think the who in this case is a bit different. So okay, the aviation side of the world, because again, when you're looking at say the man aircraft, right? You know that this is a Singapore Airlines flight. This is what number it is, who is the captain, and so on. But that is a commercial service, right? It does not tell you, for example, let's say if you are flying a private Cessna, right, or you're flying a private plane, and so on. I think that's one side of the world, and the other side of the world, like talk about, is the closer to the land transport, where people don't really know who you are. They can just say, okay, it's a man driving the car, it's a woman driving a car. That's probably about it, right? So we have not found that balance, if I may, right? Because I think there's still many opinions that are kind of in the spectrum of gray area. On one hand, we all agree that an ID is required. So as long as we have that ID, a lot of things are enabled. But on the other hand, just having the ID might not be enough. We might need to know where exactly you are, because you're just physically so far away. I can't say like you're at the curb of not at the curb or in the middle of the road and so on. I have to say that I see that drone, and the drone is at this long altitude. And in this case, for the US, for the ASTM version, you have to also report your velocity, right? And there was this final mode that was actually proposed in the standard, which is the emergency mode. Are you just flying normally, you're fine, or you're not fine? You're actually about to come down because something wrong has happened, right? So okay. I think that's the standard today, but I think the opinions are still open on whether we need a little bit more information or actually we need a little bit less information.
Yeah, makes sense. Okay. And the next question here. Oh, sorry. Were you finished with that one, or are you still trying to explain it?
No, I'm finished. The next one.
Great. The question says, in the example that you had of drones to dock, or the drone operating center, if a VPN or APN is compromised, does that affect the drones actually operating, or simply the information exchange from them?
Right. So the way we build it, and I don't know how other people build it, but the way we build it is that we would detect that VPN is compromised, right? So the drone will only volunteer its video streams and its telemetry to the internet as long as the VPN is there. If it detects that the VPN is disconnected or compromised, I mean, assuming that it knows that it's compromised, right? There's some man in the middle who joined the VPN to different story, right? But assume that it gets disconnected, it goes back into a bunch of fail-safes. So there's a bunch of fail-safes where it automatically finds the closest emergency landing point. For drones that are built with boxes, they will just find their landing box and goes back to the box for charging and so on. It will not continue with their mission unless all conditions that is required for cybersecurity is met. Right? So that's kind of our design. I wouldn't know that's the best design or not, but a lot of missions are abandoned that way because it could be the VPN is broken, or sometimes we just fly in the sky and there's insufficient cellular coverage, right? Because sometimes cellular coverage, they are still optimized to point at the ground, right? The radios, they're tilted in a certain way such that in the ground signals are better. So there might be places where we're flying that we do not have enough cellular coverage. And after a few seconds, actually, if you didn't reconnect with any cellular coverage, it also goes home. So similar fail-safes will be put in place basically for all these use cases.
Okay, that makes sense. And Masumi, I might get you to put the slides back on the screen. There was a question here, Jinju, about what was the CAS incident reporting scope and the military software requirements required for BV laws that you mentioned there, if you can touch on those.
You caught me on my last slide that I didn't finish. All right, so if you go to, so basically in Singapore, there's this ANR 101-2-0, which describes the whole beyond visual line of sight operation. If you go into that document, you will be able to find references to both the military software requirements for the high-risk operation, which actually for us, we are actually not there yet. I mean, we are still dealing with the low and the medium risk, right? So that is basically one example of anything that's been specified at all about software. But when we glance through the documentations and requirements, we find that a lot of these specifications are very much based on, again, military spec, right? So imagine you have code running on a F-15, right, or something like that, and that how the code needs to be written and checked and make sure that it doesn't fail and so on. It does not address the internet, because in general, I don't think anybody has specified when you have internet connected drones, what needs to be done. So I think that's still an area that in the next maybe 2 to 5 years, I think many USS supply, UTM players especially, right, they will have to kind of play that role of trying out different standards and discussing and trialing and convincing regulators that this is good enough, this is too much, and so on. For the incident reporting, this is an example of something that's more operational. So an example, all our drone flights today in Singapore, we need to have an operator permit as well as an activity permit. So as part of the activity permit framework, there will be a number to call. There will be when something doesn't happen according to whatever was planned and applied for, you must notify CS immediately and submit an incident report in 3 days. One of my biggest kind of next step of questions that I can figure out is when a cybersecurity incident happens on a drone system, but no drones are flying, is that an incident? Because all our systems in the cloud are running 24/7, like any SaaS, right? And let's say all the drones are grounded at that point, right? But it was compromised, right? Would that correspond to an incident? In banking or any other environment, that would definitely be an incident. But for aviation, it's still kind of undefined because they all often care about things when things are flying, not when things are on the ground, right? So those are just open-ended questions that we have not been able to fully address, and I'm sure there are a lot more.
Yeah, that is a really interesting point, and I'm sure we could talk about this for a lot longer because there has been UTM, compromises. There's been compromises of fleet operational software, counter drone systems, and when you think about it, it's an incident that relates to drones, but it might not necessarily affect them in the air. So that's that aviation and kind of cybersecurity worlds colliding. So makes sense. Look, Jinju, there's one last question, and I guess this one's more of a personal basis, but you talked about Flight Radar 24, and I think of FleetMon as well, about tracking all the ships and things like that. Do you visualize a potential for the public to be able to access an online or open service like that, to be able to see drones everywhere and see those identifiers? Or is this more of a private-based thing or something based on an app? What's the scope of being able to access something like that at this point?
I think at this point, we can all agree, at least if you follow kind of the FAA thinking, right? We can all agree that if we can see the drone visually, right, we should be able to know who it is, or at least the ID, basically, right? We should know that we should have an app somewhat that shows a drone appearing on the app if we can visually see it. That usually means then a few hundred meters, right? So there might not be an app at this point to say, like, to show you the whole world where all the drones are, or even the whole country, unless your country is really, really small. Right? But you can definitely see everybody who is nearby you, because those are the ones that you need to know and watch out for in case they collide into you, right? Or maybe they are shooting a video of you if you don't want to because of privacy reasons, right? So if you are at home and they will hear some buzzing sound in the vicinity, you should be able to get to your phone and say, hey, there's a drone flying in my vicinity, which I did not expect, right? I want to find out what ID is that drone. That said, I do believe that for commercial operators, and for military operators and so on, the guys who are not the general public, right, the general hobbyists, but people who are kind of either have a license or inducted into that kind of a environment where safe flying is mandatory, let's say, right? Because if you're doing work for flying drones for doing work, then I think you might have a little bit more access for a much larger area. Take, for example, if you're going to do a beyond visual line of sight operation, right, and you're going to deliver something from point to point B and the thing is quite far away, you actually need a very large area, right? You need to know all the drones that's operating over a very large area, right? And basically, if, let's say if a BVLOS corridor, then that corridor and then maybe 100 meters out along that corridor, you actually need to know all the drones that's operating there. So given specific exemptions, I do believe that the government, especially whoever is authorizing this beyond visual line of sight operations, would have to find that kind of compromise. They cannot say that, because it's just broadcast remote ID, I will not tell you everything else. Because pilots are eventually still liable for their flights. They still decide whether to proceed their mission or not, right? So they need as much information, as much situational awareness about their situation as much as possible. So again, so the kind of summary is I don't believe there's going to be a national or global thing at this point. And I don't necessarily think that I want to know that, because the projection right now is that for every 737 or 747, you're going to have 1 million drones, right, in the next 30 years. So, but at the same time, I want to know every single flying object as much as possible in my vicinity if I'm going to be operating in a certain way.
Yeah, absolutely. Makes sense. Well, Jinju, thank you very much for coming on board with the GDSN. Appreciate you as a first-time speaker. And we're not in person anymore, so if you can put emojis or emoticons or your words of thanks to Jinju for attending, we'd appreciate that. And Jinju, we'll see you soon. So thank you and goodbye.
Bye.
Okay, for everyone else, we are going to be moving on to Antoine very soon. So we'll be back in roughly 7 minutes to kick off the next session. Thank you. Okay, thank you everyone for rejoining us, and we have Antoine from CerbAir in the chat here. And Antoine, do you want to give us a hello? Check the mic is working.
Sure. Hello. Is everything okay? Is everything working?
Sounds perfect. So after this, you'll get to share your slides and take it away. So thank you for joining us, and I'll let you continue with your presentation.
Thank you very much, Mike. Hello everyone. My name is Antoine Menini, and I'm the CTO of CerbAir. CerbAir is a French company that is specialized in providing counter-drone system. The company was created in 2015. We develop, manufacture, and sell our own counter-drone solution based on radio frequency detection, and we work with major French and international government institutions. Today, I'm going to talk to you about the miniaturization of drones and its impact on radar versus RF detection. We are going hopefully to debunk some common myths about drone detection, and I'll try to show you why RF detection still remains a good choice when it comes to detecting drones. Oh. Sorry. So first, let's have a look at the biggest drone manufacturer in the world, which is DJI. You will see in this slide the evolution of their consumer drones from the first DJI Phantom that was in 2013 to the latest DJI Mavic Mini 2 that was released just last year. Also, it was a bestseller. DJI has now abandoned the Phantom series to focus on the Mavic series, whose drones are way smaller and easier to carry around than the Phantom ones. You see, for instance, that the DJI Phantom, the first one weighed 1,200 grams, while the weight of the latest Mavic Mini 2 is only 249 grams. And we see the same patterns with other big drone manufacturers, such as Parrot, with their Anafi drone, for instance, which is also a very small drone. And we'll try to have a look now at what makes this evolution possible. So drones are becoming more and more intelligent with more sensors, more features, better cameras. At the same time, they are becoming smaller. So this change is mostly driven by the smartphone industry. The race to better smartphone cameras and more processing powers has allowed electronic manufacturers to get better components that are at the same time also cheaper. Let's take, for example, the ARM CPU architecture. If you have a smartphone, most likely it will use this kind of processor rather than the x86 Intel architecture used by a computer. The advantages of this architecture is that it consumes less power, therefore produces less heat, while at the same time being small in size. Apple has even decided to make a computer with this exact architecture. This is the Apple M1, which is used in the latest MacBook. So the ARM architecture is really great for low power consumption, and this improvement in low power CPU are now used in drones to allow them to have more processing power. Cameras have also improved a lot in the last year. So you might have noticed that current generation of smartphones now have 2, 3 more cameras that have high resolution, and the same sensors that are used in smartphone can be used in drones to get awesome pictures. If we compare, for instance, the size of the camera of a DJI Phantom with the latest cameras of the Mavics, we see that the size has decreased a lot, and at the same time, the resolution and the quality has increased. So these major pushes on the smartphone industry also benefits the drone industry. Batteries represent almost a third of a drone's weight. Battery technology has also faced a strong evolution. First, also because of the smartphone industry. Now the batteries on the smartphone are getting better and better every year. But also more recently, thanks to the research on electric vehicles and electric cars. This means that nowadays the battery can deliver the same amount of energy and are lighter than before, which lead to smaller motors in drones, smaller propellers, and in the end, increased autonomy. So some studies suggest that the battery energy density, so this is a ratio of energy per unit of weight in a battery, has tripled since 2010. This means that we are now able to put 3 times more energy in the same battery than we were able 10 years ago. And the drones that we see now, the DJI Mavic Airs, for instance, were technologically not able to exist 10 years ago. The way we use drones has also changed a lot. So 10 years ago, drone couldn't do a lot except for maybe flying a little bit, not far away, not a very long range. The battery didn't last as long as today, and flying a drone was more than a hobby. Most of us remember the first drones that were really big and that you had to carry around in a big backpack. This has changed a lot. Now drones are smaller, more affordable, and capable of a lot of things, and people view them more like a tool to take great pictures or video while doing other stuff. For instance, now when you are doing sports like skiing or running, the drones are automatically able to follow you outdoors and to take great pictures of you. So they are now viewed as a companion in leisure rather than a leisure themselves, and therefore they have to be able to be packed in a suitcase very easily. This was not the case in the first generation of drones. Regulation is also a major incentive for drone manufacturers to come up with drones that are under some weight limit, so that users of drones will get less restrictions. A good example of this is the new drone regulation that was just passed in the European Union. As you see in the table, the regulation organizes drones into different categories: C0, C1, C2, C3, and these categories are based on their weight. So you see that the law is not the same for all types of drones, and drones under 250 grams require no training at all and can even be exempt for registration if they are considered as a toy. So I'm sure that now you might probably understand why the new Mavic Mini 2 weighs exactly 349 grams, so that users are able to use it almost freely without being able to to have any regulation difficulties. So all of this pushes for drones that are smaller, but now let's have a look at the consequences on radar detection that these smaller drones have. So first of all, what is radar detection and how does the radar work? Radar is a tool that detects physical objects. Basically, what it does is that it sends an electromagnetic wave at a very specific frequency. This wave is then reflected on the object, that's called the echo, and the echo is used to determine the direction and the distance of the reflecting object. If the object is moving, the frequency will slightly shift on the echo, and this is called the Doppler effect. So we can use this effect to get the speeds of the object relative to the radar. Radar is a great technology that has been used since World War II as the primary way to detect airplanes all around the world. So it's really a great tool, but it's kind of difficult to use in drone detection. The first problem with radar when dealing with drones is the range. In order to be able to properly analyze the return signal, this signal, of course, has to be strong enough. The proportion of the reflected signal on an object is called the radar cross-section, or the RCS. Radar cross-section depends on many factors. First of all, for instance, the material of which the target is made, the size of the target relative to the wavelengths of the radar signal. So this is the frequency. But one of the most important is the size of the target. And so as drones are becoming smaller and smaller, they are made out of plastics, then the RCS, the radar cross-section of the drones, is also becoming smaller, and it's really difficult to detect them at long range. So we need more and more powerful radars to detect these types of drones. Radar also will detect everything. As we see, they send a wave, the wave is reflected, and everything will reflect the wave. So we need a treatment, we need to apply a treatment to eliminate what is called the ground clutter. Clutter basically is the reflection on everything with the radar. So the wave will be reflected by the ground, by buildings, by trees, by almost anything. So the first process that is being used is called moving target indication, or MTI. This process is based on the speed of the object that is detected. And we want to eliminate stationary objects to be able to filter out the clutter. The problem with drones, compared to airplanes, for instance, is that they can move very slowly. Or they can even stay stationary. So it's very difficult to find a good threshold. If the threshold, for instance, is too low, you will detect everything. You will detect the ground. You will detect the buildings. You will detect everything. But if the threshold is too high, you will not detect drones that are moving slowly or that are stationary. So engineers have come up with new solutions to face this issue. So also, the process is not perfect because there are other moving objects that we want to eliminate, like branches or trees or people walking or cars. So engineers have come up with a new solution and a new way of discriminating targets. This way is called a stationary target indication, or STI. Here, the idea is to exploit some intrinsic characteristic of the moving object, like, for instance, the apparent size, which is relatively small compared to ground clutter. So, for instance, the building will reflect a lot of energy, whereas drones or smaller objects like that will reflect smaller energy, we will be at a different distance. So this is used a lot to do discrimination of targets. But the problem is that there are other targets that we would like to discriminate, like birds, for instance. Birds causes a lot of problems with radars because their size is approximately the same as drones. And so the radar cross-section of birds is approximately the same. Birds, as you know, are made mostly out of water, and water reflects radar signals a lot. So we need a way to discriminate birds against drones. So most of the times, this way is the micro-Doppler effect. So we already saw in the previous slide the Doppler effect, which shifts the frequency of the return signal if the detected object is moving. So now, if the detected object or any structure on the detected object has mechanical vibration or rotation, it will induce a frequency modulation on the return signal. This frequency modulation can be detected, and this way we can see what type of object we are detecting. And so this is typically the case of the drone's propellers, which are rotating when the drone is flying. And this is a great way to discriminate drones against birds because they have a different micro-Doppler signature. However, you have to understand that this effect strongly depends on the size of the moving object and of the material of which they are made. So drones are becoming smaller, so their propellers are becoming smaller. So it's becoming more and more difficult to detect them using micro-Doppler effect because the propellers are now made out of plastic. They are not made out of metal anymore. And the effect of the micro-Doppler is also stronger on quadcopters than on fixed-wing drones, because fixed-wing drones have generally only one propeller. And finally, it's important to understand that the detection of the micro-Doppler effect is only possible at a distance range shorter than the standard detection distance. So if the range of the radar gets lower, then the range of the micro-Doppler detection gets also lower. For instance, so if we take quadcopter drones and a radar that has a detection range of about 1 kilometer, for instance, then the range at which we'll be able to detect the micro-Doppler effect will be something like 500 meters. So as drones are becoming smaller and smaller, it's really difficult for radars to be able to detect them because of the physics of the radars and of the physics of the waves. So in conclusion, we see that drones are getting smaller thanks to new available technology, mostly available technology made of consumer smartphone markets. But obviously, the strength has also some limits. So for instance, smaller drones would have more difficulties to fly during high wind. And so the smallest of the drones, you see sometimes nano drones that are like 10 centimeters wide. These nano drones are really difficult to fly outside because of the wind. Also, in order to be effective, the communication antennas of a drone need to have a certain size. So typically, for instance, at 2.4 gigahertz, the typical size of an antenna to work properly is 6 centimeters. So if we want to lower the size of the drone, we'll need at some point to decrease the size of the antenna, and this will not be great for propagation. Also, batteries are getting more effective, but as we saw, battery only represents a certain percentage of the drone total weight. We saw that on DJI drones, battery represents approximately a third of the drone's total weight. So even if battery technology will most likely continue to improve in the future, thanks to smartphones, thanks to electric cars, we'll still need other parts on the drone. We'll still need motors, we'll still need propellers and other components that are more difficult to miniaturize. So that means that the effect to that miniaturized drones also have some physical limits. But as a matter of fact, they are still continue to becoming smaller and smaller, and it's more difficult for radar to detect them at reasonable range because, again, of the physics. For instance, you can see this nano military drone on the right of the screen. This drone is called the Black Hornet. So even if the flight capabilities are not the same, of course, as the one of bigger drones, this drone is almost impossible to detect using radar technology. So this is where other complementary technology can be used to detect drone, and one of them is passive RF technology. So let's have a look at what passive RF technology is. Most of the time, when you use a drone, there is a bidirectional communication between the drone and the pilot in order to fulfill a mission. So the pilot, with the remote control, will send command to the drone, and the drone will send back the telemetry data, so real-time position, speed, sensor status. But most importantly, the drone will also send a real-time video link. The pilot, most of the time, is able to see in real time what the drone is doing, what the drone is filming. So the principle of passive RF system is to detect this two-way communication. Most of the time, this kind of system relies on the drone signals database and is able to detect both the drone and the pilot. So one of the great things about this type of system is that it does not depend at all on the physical size of the drone. A nano drone, a small drone, can be detected as easily as a big drone that is 10 meters wide, provided, of course, that the signal power is the same on both drones. Also, contrary to radars, it does not need any direct line of sight between the drone and the detector. So RF detection is a great technology that is very complementary to radars. But many people argue that today, with the state of technology in artificial intelligence, we can have drones that are fully autonomous and that have no data link at all. Drone can be programmed using GPS waypoints or even image recognition algorithms to perform their mission without being controlled from the ground. So for such drones, of course, passive RF detection is simply not possible, as it relies on radio frequency communication between the drone and the pilot. So if there is no communication, if there is no radio frequency whatsoever, we cannot detect it, of course. So such technology exists a little bit, but we'll see that it's far from perfect, does not work, it's not magic, and also it's operationally quite difficult to use. So we'll see some examples of this. So why is it difficult to have drones that are fully autonomous? It's because communication when using drones is essential. So communication takes a vital part in a drone's missions, whether they are civilian, military, benevolent drone, malicious drones. Communication is really important. So let's imagine, for instance, that you have a reconnaissance mission and you want to explore the site to obtain some information about enemy presence, activity. Of course, it's a good idea to send a drone because you will reduce the risk on the operators. You send a drone first, and then maybe you do something else. the thing is that you don't necessarily know in advance what you will look for and where you will need to look. You can imagine, of course, filming with the drone without any transmission. So you store the data on the drone performs its pre-programmed mission, and then when the drone comes back, you can retrieve the data and see everything that the drone has filmed. But what it means is that the information that we'll get from this could be outdated. During the 10 minutes of the mission, things could change, people can move, and also you risk losing the drone, because if you lose the drone, if the drone is shot, if the drone has a technical problem or anything, you will get no information at all from this. So we see that live information for reconnaissance is really key. That's why most of the time, even if the drone is pre-programmed, the operators want to get the live video of the drone to be able to see what's important and to be able to change the mission. So imagine now that you want to use a drone to destroy a target, for instance. So drones are used a lot for target designation because they are quite precise, and also because we reduce the risk as well for the operators. But drones are also used directly as a means of attack. So obviously, you can program a drone. Obviously, you can program a drone using GPS waypoints, and you can program it to attack a precise position based on the geographical coordinates of the position. But there are some drawbacks that you must take into account. So first of all, the position of the drone using GPS will most probably be inaccurate by a few meters. It's not a lot because GPS signals are quite accurate, but this could cause you to miss the target, especially considering that most of the time drone payloads are limited. So precision in hitting the target is a key. So programmed drones are not very good to attack target. Second, if you do this, you will rely solely on GNSS satellite signals, and this GNSS satellite signal can be spoofed or jammed, and this could destroy the mission. Also, the target has to be stationary, so you cannot use GPS waypoints to attack a convoy, to attack a moving person. So we see here that with these two small examples, even if technologically we can program a drone to perform some missions, operationally it's a little bit more difficult than that. It's not as easy as just pressing two buttons, saying, okay, I select this target, attack this target. Unfortunately, communication between the drone and the operator is still essential. Then we'll see that identification is also essential. So you might know that drone regulation all around the world is pushing for drone remote identification. So if I take the example of France, for instance, that I know quite well, France has passed a law that requires drones over 800 grams to constantly send in the air their identification number as well as their live position. The EU and the US are working on quite a similar regulation, and this will allow authorities to control drones way more easily. But this type of system is also very important for military drones, even if the purpose for military drones is a little bit different. It's very important, operationally speaking, to be able to recognize your own drones when you are flying them to avoid unintentional friendly fire. For a long time, as you might know, airplanes have been equipped with IFF system, identification friends of foe, which uses radio transponder to identify the broadcaster. This is really important because as more and more airplanes are flying, if you don't have a clear situation, especially during war, you can have issues. In 2003, for example, during the Second Gulf War in Iraq, a British Tornado was shot by American Patriot missile, so friendly shot, because of technical deficiencies with the IFF system. So we see that it's very important to be able to communicate with your drone, but also to be able to identify your drones. So, as a conclusion, there are, of course, a lot of trends in artificial intelligence and autonomy. We see it for autonomous vehicle, and we see it, of course, with drones. But we see that drones rely a lot on communication to perform the mission. So most probably, they will continue to use RF data link and to be detectable by passive RF system. At the same time, the technology allows for these drones to be smaller and smaller while performing the same mission. So of course, radar technology is great and will continue to stay a primary way to detect moving objects like drones. But we see that there are some drawbacks and that radars face a lot of difficulties when dealing with drones, especially if the drones are smaller and smaller. Sure, it's a little bit easier to detect a big Reaper, a big military drone using radar, but for nano drones, as the one that we have seen before, it's much more difficult. And this is where passive RF technology, I think, will always be a great complementary choice. And of course, the best solution is to have the two of them working together. So this is the end of my presentation. Thank you very much for listening to me, and I'm happy to answer any question that you might have on the internet.
Brilliant. Thank you very much for the presentation, Antoine. And I know we do have a few questions. So starting off, and it was quite interesting, I must say, on the RF silence side, we've got something on that. But the first question I want to ask you was, what is the difference between, mainly focusing your detection on, say, smaller systems versus some of the larger drones that can carry heavier payloads?
Well, it depends strongly on the threats that you have and what you want to detect. So, for example, if you are a military, you might want to detect bigger drones that have higher payload because the threat that you face is basically bombing, and the opponents that you have, they will use bigger drones. If you want to protect a sensitive site, the biggest threat that you might have is spying. And spying, as we have seen, can be done using small drones like the DJI Mavic Mini, for instance, which are like consumer drones that are all available and not expensive at all, but they can even use smallest Black Hornet drones. So I would say that it strongly depends on what problem you are facing and what you want to protect against.
Okay, yeah, brilliant. And the next question touches on the previous speaker who was talking about the cellular networks that are controlling drones from, say, a drone operation control center. So with some of those cellular networks starting to interact or control drones autonomously, will RF detection systems still be relevant in these scenarios?
So, of course, cellular networks poses a major threat to RF detection. RF detection relies on drone signatures, and if drone use 4G networks or 5G networks, the signature will not be any different than with a smartphone. So it causes issue with RF technology. Of course, there are solutions to this. But I don't think that all of drones will start using 5G in the next few years because it's really complicated. Basically, drone 4G has been available for a long time now, and drone can be controlled by 4G. But even with this, you see that there are not a lot of consumer drones that use it because of the complexity and because you rely on something else. Whereas if you have your own drones with its own communication, you rely only on your communication. So it's a little bit easier to handle, especially in war scenes. It's easier to have your own communication than to rely on 4G, which is not reliable at all and can be jammed.
Okay. Yeah, very interesting. And I think, technology will catch up to that point when that is happening. And a lot of the malicious, pilots will probably not choose to go along those lines of remote ID or interconnected systems just yet. So, okay,
exactly.
interesting.
And you have to consider also that if you use 5G communication, it's easier to trace you because you will need a SIM card. You will need to be registered on a certain network. So of course, it's a little bit more difficult to detect. But at the same time, if you are malicious and you use cellular communication, it's easier to trace you. So that's one of the drawbacks.
Okay, very interesting. So the next question, Antoine, was how will RF detector systems fare when it comes to small, fast-moving drone swarms or multiple drones at the same time?
So that's a really good question. Drones nowadays you can have a lot of drones using the same frequencies. Of course, drones are made and signals are made to be used at the same time. So if you see smartphones or Wi-Fi, you can have a lot of Wi-Fi discussing at the same time, a lot of Wi-Fi device and lots of smartphones. And it's kind of the same with drones. Also, drones have to send a lot of data because most of the time they send a huge video file with high quality, but you could imagine having 10, 15, 20 drones flying at the same time. Of course, it poses issues to RF detection because, again, it's a little bit more difficult to detect when there are a lot of them flying on the same frequency range. But we've seen, and we have seen this with our system, that if the drones are able to communicate together without a lot of interferences, we are also able to detect them without much issues. And the same thing the same difficulties will happen to radars. When there are a lot of tracks on the radar, it's a little bit more difficult to detect.
Okay, no, it makes sense. And a question from me on the back of that is, if you have an RF link that is being established when the drone is on the ground and the pilot is turning it on, versus a drone that was turned on a lot further away and comes into range, will you detect, or will the systems with RF detect that drone initially starting up when it's on the ground, or does it fare better? Yeah, go ahead.
Yes, so if it's on the range, we're able to detect the drone and the pilot, even if the drone is not flying yet. So this is one of the great things with RF detection. If you want to start a drone not far away from the system, as soon as you start the drone and as soon as the drone and the pilot start communicating together, both will be detected. So if you have jamming, for instance, you could start the jammers, and the drone will not be able to take off, basically.
Okay, very interesting. Now, there's another question here that I'm going to continue down the RF space with, and it says, what about RF in RF heavy environments? Sometimes we see testing conducted in aerodromes rather than the city where there's lots of critical infrastructure. I think they're trying to say in cities where there's RF heavy environments or places like critical infrastructure with probably unique or nuanced RF signatures.
Yes, of course. So this is also one of the drawbacks with RF is that it depends a lot on the environment. So if you have an RF IV environment, as you said, it's way more difficult to detect. So you will lose some range, obviously, and you will not be able to detect the drones a few kilometers away, as you will do in non-urban environment. But the thing is that at some point the drone will need to communicate with the pilot, and so in RF AV environment, most of the time you will see that the pilot will also lose range on the drone. So the pilot will need to be closer to the drone in order to be able to fly it. So the drone will come from closer, you will be able to detect it. So of course, it causes issues on the RF system, but the same issues are caused to the drone and to the pilot of the drone. And so one of the force of the CerbAir system that we are developing is that we try to filter and to eliminate all this noise to be able to detect only what's relevant inside of it.
Okay, and just out of interest, when you are, say, testing your detection systems, would that testing take place in replicas of real life environments, or is it always usually done in, say, a Faraday cage or a closed environment or an open field? You know, what's your testing journey been like in terms of trying to get that right and measure out those filters?
Yes, so of course, most of the time we test our system in open field, but we also like to test our systems in real life environment a lot. So for this, of course, we have installation on customer sites from which we're able to get a lot of feedback. But also we like to move our system. So last week I was right at the center of Paris. You can imagine that there are lots of Wi-Fi networks, a lot of cellular networks in the center of Paris. So the RF environment is quite horrible. But we like to test our system in this type of environment and to get some data to continuously improve our algorithms.
Okay. Talking about your own algorithms might be an interesting intro for this question here. It says, if innovation in drones is being driven by smartphones and batteries, what is driving best of class RF detection in terms of innovation, or what is RF gold standard?
That's a good question. So I think that the best in class RF system is driven by simply by the counter drone industry. We see that for like 5 years, when CerbAir began working on its project, there were like 3, 4, 5 companies that were doing counter UAV systems. And now there are more than 300 companies in the world that are doing it. So there are top-notch engineers that are working all over the world to find out a solution to detect drones, because it's really difficult to detect them using RF technology, using radar. The technology is quite difficult to master, but at the same time, there is a lot of demand to be able to detect drones and to be able to protect against malicious drones. It could be on airports, it could be on stadiums, prisons, cities, military sites. So there are lots of sites that have threats because of drones. So I think that demand is what is pushing the market.
Okay, brilliant. And there's a question as well that said, have you ever tried to detect the Black Hornet drones, as you showed in the end of your presentation?
So this is a military drone. So CerbAir does not focus itself on military drone. Also, we sell our solutions to military people, but our goal is to detect commercially available drones. So Black Hornet is not one of the commercially available drones. So it's not what we focus on, so I could not discuss it further.
Okay, that's a good answer. And I guess at the same time, if you think about, say, Parrot, even that it comes out with commercial or enterprise, and then drones that are used within blue SUAS or kind of military standard, where does your bar kind of sit in terms of those are the ones we'll focus on to detect versus those ones we'll leave out?
So this is a difficult question, but of course, so that's why the goal of CerbAir is to detect commercially available drones, because if the drones is commercially available, everyone could use it and everyone could use it maliciously. If the drone is specialized for any forces or stuff like that, then it's a gray area for us, and we don't want to detect it because it could also cause some issues for our users. So the red line for us is we detect drones that are commercially and freely available on the market, and we don't try to detect drones that are not. So that does not mean that we are not able to detect them, but we don't focus on them.
Yeah, brilliant. Okay. And I've got another one here from that came in from Twitter. It said, some countries allow the demodulation and decoding of RF signals, as in it's illegal in terms of law. How could you advise when it comes to detection? Are you banned from detection in any countries?
Not that I know of. So you have to know that we don't do any signal demodulation. So we are able to detect the packet. So we know that there is a communication between the drone and the pilot, but we don't know what this communication is. So this is a big difference between our type of system and other types of system that do basically like signal listening and signal demodulation, and that are a little bit more difficult to use because of the regulation. From my knowledge, there are no limits to the use of detection, passive RF detection system, because they are listening to signal that is everywhere, but they are not trying to understand what the signal is telling.
Okay, brilliant. And we might go for one last one, unless any more come in. And that is, what is the difference between having many small hardware RF detection systems versus one large RF detection system at, say, around an airport?
So it's a big question. It's a good question. So first, you have to understand that there's a big difference between radars and RF for this topic. So radars, the range of a radar depends on the radar itself. So it depends on the strength of the signal that is being sent by the radar. So there are radars that can detect drones at more than 10 kilometers, even if, as we saw, it's very difficult. But there are radars that are very short range and that can detect drones up to 500 meters, 200, 100 meters. For passive RF system, it's a little bit different because our range depends on the signal that is emitted by the drone. So it's not like you can build a system that has a very short range and then another system that has really long range. Of course, there are things that you can do, but most of the time, all the stuff depends mostly on your algorithm, the quality of your material. So you could, for instance, for airport, if you want to protect an airport, you will need to put several RF system at several sites, several points on the airport, because airports are very big sites. So one system only would not be able to detect drones flying all over an airport. So this is one of the reasons why you want to put multiple systems. Another reason would be to prevent from communication. So some of the times it's really difficult to find a good spot to put one RF system, because the good spots are already taken by cellular mobile antennas. So this way, maybe you want to put multiple systems at multiple sites, so that you can take advantage of this and have less interferences.
So if you don't mind, I just want to dig into that. If you were going to a site and you were looking for the perfect place to put your RF detection sensor, what would your thought process be, and what would be the most ideal site to place that for the greatest coverage and range?
So when we do this, we do what we call the site survey. So we have engineers coming to the site, and they are trying to determine what is the best position to put the system. So of course, RF system needs to be put high in the air because it causes less interferences, because the drones that we want to detect will also fly a little bit high. And so we first try to find the high points on the buildings, and then we try to listen with our equipment to any RF signal, because, for instance, if you have a huge Wi-Fi antenna just near our system, it will cause issues. So we try to determine the best position based on height, but also on any other RF signal that is coming. It could be mobile signals as well as Wi-Fi signals most of the time.
Okay, great. And another question did come through. If you're still in the mood for answering them,
Yeah.
apologies for shooting so many at you. But look, let's get through them. So another one says, is there any limit to RF detection on the amount of drones in a drone swarm scenario? You know, maybe you can talk to your own experiences, or maybe theoretical. But maybe what are those limits?
So there are of course limits. We will not be able to detect all the drones if there are thousands of drones, for instance. But I would say that the physical limit is more for the drone swarms than for our system. So if you have thousands or 2,000 of drones, for instance, you will not be able to communicate with them in real time. You will not be able to get a real-time live video of all of them at the same time in the same frequency band, because it's just physically not possible. So of course, this physical limitation will cause physical limitation on our systems, but you will need to reduce anyway the amount of data that you will transmit between all the drones. So this causes us to this poses more difficulty to detect the drones, but the difficulty is also on the drone swarm.
Okay. Yes. Very interesting. Okay, so I think we're almost at the end. I've checked and I haven't seen any new kind of questions coming in. So Antoine, we thank you very much for your presentation and for your time, and for coming back as CerbAir for a second speaker at GDSN. We really appreciate you talking about these, and I found it very interesting as well. So what we're going to do next is I'll let you say goodbye, and then we're going to take a 10-minute break before we come back to Victor from Parrot sharing his next presentation. So Antoine, again, thank you very much for coming.
Thank you. Thank you very much, everyone. Have a good day. Bye.
All right. We will be back in roughly 10 minutes to resume with the next part of the session. All right, brilliant. We are back live, so hopefully people are making their way back to the stream. And well, we're very lucky to have Victor return to the GDSN. So Victor was with us last time and kind of hinted a little bit at the time, I think, about an impending or incoming bug bounty. And now obviously it's a reality. So Victor, why don't you give your mic check, say hello, and I'll confirm for you.
Hello, everybody, and nice to be at GDSN again. It's a real pleasure for me. And I talk to you today about cybersecurity at Parrot and what brought us to bug bounty. So just before starting, here we go. I don't know if you see my slide. Yes, you do. It was quite important to explain the whole journey to bug bounty, because at the end of the day, bug bounty is, I wouldn't say kind of an accomplishment, but it's there because we had a few steps before, and it makes sense. It makes sense because we did a lot before that. So just before I begin on cybersecurity, just a few information concerning Parrot for those that don't know us. So we design and manufacture small drones, and our latest product is Counter-UAS, which is an awesome drone. Really, it's quite small and it can be unpacked in less than a minute. It's really quiet, but still it has an awesome capability, and it can zoom 32 times, which means that you can basically see someone at 2 kilometers away and see if that people got a gun or have a precise view of what's happening there. And of course, cybersecurity and trust is also quite important, because this drone is made in the US and we had careful choice of components so that it's NDA compliant. So here is basically what's about Counter-UAS, an awesome small drone, but very powerful and of course secured. So first, let's talk about security by design. It's not quite easy to define security by design, because there can be a lot under this definition. But first, it's important to mention that for us, security by design begins with people. People is quite important because that's them that design the product, develop and implement what's in the product. So security awareness at Parrot is not just a matter of security team. It's really a concept. It's awareness that is spread across the whole organization, from the CEO to product managers to developers. And basically everybody is aware of cybersecurity. And to me, that's one of the main points. It's quite important that people get involved, that people understand what are the security needs, and understand that it's important to protect clients' data. So for me, it works first because people are there. People are really have a wide range of skill sets at Parrot, and among those skill sets, they get better and better at understanding security and implementing security. So that's the first point, and this allows us to implement security from the beginning of projects. There's many products for which cybersecurity is kind of an add-on. It's done afterward, sometimes at the end of the development of a product, or even from times to times after it's out on the market. And it's quite different at Parrot, because cybersecurity is there from the beginning. And when we start a project, we wonder what is the real need and what we have to improve into that product compared to previous ones. So as far as it's a priority for Parrot, we define it just the same way that we would define that a drone would have to fly for this amount of time and would have to see with this amount of zoom or thermal capability and so on. So cybersecurity is there, and it's there from the beginning. And cybersecurity is not just a matter of implementing it in-house at Parrot. It's important to have this broad view and global view, and to include all suppliers and especially all the supply chain that provides some components or from time to time help us to implement part of the software. So concerning this supply chain, we've seen in the past a few products in the electronic consumers part that might be backdoored or may have huge vulnerabilities. So it's quite important at Parrot that we check what is the level of security of the different suppliers, and we make sure that we trust where the components come from. So that was a real need for NDA compliance and for Blue SOS program for Anafi USA, but it's now part of the way we do things. So it's a great improvement also. And of course, when we speak about security by design, it's important to do it at the very beginning and define what the security needs is and what the different security features will be. Then implement, but also check. And that's what we will focus on when we speak about audits and bug bounty, because this part is quite important. And this cycle helps us to implement continuous security improvements, which means that over time, be it for one product and also from product to future products, we continuously improve cybersecurity, which means that in the previous years, we've done a lot so far, but we won't stop there, and we will continue to keep integrating even more security and protect users' data always better, so that we make sure that we minimize the potential impact of a defect if one day there's one. So here are some example of questions we could ask ourselves when we design a product. And by the way, that's also that kind of question that clients ask to Parrot just to understand how we implement security. So when we've got a drone, most of people would wonder how we authenticate and encrypt the radio link between the remote controller and the drone. They would understand how we protect the user data that is stored on the drone, and how we would protect the drone itself, because it's important that no attacker could put a malicious software into the drone. And for some people, it's also quite important to protect flight data, for example, from forensics analysis, because if a drone is lost or caught by an adverse party, you may not want this adverse party to understand where you took off, where you've been flying for this mission or for previous missions. So it's important also, especially for defense and sometimes for public safety, to also protect this kind of data. So once we've defined the security need, of course, we implement solutions. So here are just a few examples of those solutions. So if you wonder how we authenticate and encrypt the radio link between the remote controller and the drone, So basically, we use a standard WPA2 protocol, and we define for each pair of drone and remote controller a unique key. So first, the fact that there's a unique key makes it secure by default, because there's no default password that an attacker could guess or could reuse very easily. But then that's not the only thing we define, because even if it's unique by default, the user can define its own just to make sure it's his password and not just one defined by Parrot. If you wonder how we protect data that is stored on the drone, so that's one of the best enhancements on ANAF-USA. We implement a full disk encryption on the SD card. So basically, all photos and videos taken by the drone is stored into this SD card, and we don't encrypt data file by file, but the whole disk is encrypted. And that's great because it allows to protect every data, and it also prevents some forensics techniques that would be used, for example, to retrieve just one data or try to intercept part of the data before it's encrypted. So here, everything is encrypted, and we use best-in-class algorithms. Just to name it, AES XTS with 512-bit key length. And what's quite important is that we don't stick to marketing cybersecurity. We also implemented the right way. For example, with XTS, we choose the right block mode of operation. We choose the longest possible key length. And the most important thing is that we make sure that this key is never stored on the drone. Because if the drone is lost, someone could try to retrieve this key. And here it's completely different, because to make it secure, we have this key that is stored into the software that is in the remote controller. And when it's paired to the drone, the remote controller transmits the key to the drone in a secure manner. This key is never written into the drone, so it's never written to disk and only used on volatile memory, which means that if the drone is lost, as far as access to the volatile memory is protected, as far as the drone is switched off, everything is just lost, and nobody can retrieve the key that would allow an attacker to decrypt data. So it's important not just to stick to the security features, but also to implement it the right way. So just to continue to the different questions. So if you wonder how to ensure the embedded system integrity and make sure that no attacker would put a malicious software into the drone. So what's quite important is that first we harden the system so that there's no remote access to the embedded system and no way to connect to the operating system. But then when the software evolves, the drone makes sure that there's a legit digital signature before applying a firmware update. So doing that, we make sure that this firmware really comes from Parrot, and we make sure that if an attacker tries to modify just one bit, the attacker won't be able to push this update, because the drone would notice that there's a 1-bit difference, which would make the digital signature invalid and the update disregarded. So that's one of the examples of the way we protect the system. And finally, how do we protect flight data from forensics analysis? So it's not implemented on all versions of drones, but for security editions, which mean governmental use, we have additional anti-forensics techniques that prevent an attacker from accessing flight data, return to home or return to position, and any data that the drone would have to keep in memory during the flight, just so that things go well. So it's important because we could say there's no data stored on the drone, but when the flight, you're during the flight, you need some data. For example, if you lose the radio link between the remote controller and the drone has a return to home, or you could even define a return to position. So you define a position before takeoff, so that the drone won't go back to you, but to a defined position, so that an adverse party won't guess where you are. So if you want to protect all those data, you have to make sure that nothing is written to disk and data is protected, so that no one can retrieve this. And last, concerning data, of course, we can fly our drones with no internet connection. And there's a way to put firmware updates completely offline and import maps offline, and there's no mechanism to unlock fly in no-fly zones. So, for example, if you're a cop and you need to fly in an airport because let's say there's a terrorist attack and you need to fly into this space, there's no need for you to say, hey, I'm a cop, and ask to pirate the ability to fly in this zone. So we think that pilots have to be responsible and don't have to necessarily really ask to pirate to have the right to fly when they need to. So basically, you don't need any internet connection, nor during the flight, nor before the flight. You can do just everything offline, which is quite different from some competitors, because they say you can do this or this offline, but in one step or another, at the end of the day, you need some kind of connection. During the beginning of the presentation, I was speaking about continuous improvement. So it's quite important for us to see the future and to implement always better cybersecurity. So last year, we announced a partnership with WiseKey, which is a provider of secure elements. And this will have a great place into implementing security in our next models of drones. So it's a great component because it helps the drone to keep some information secrets. So it's just like a safe, and it also computes some cryptographic functions in a secure manner. So this way we make sure that this information stays secret and is computing the right way. So this, I guess we will be able to speak about this into greater details quite soon. So we've been speaking about security by design, and you've seen that from security awareness and the importance of people, from the way we implement security from the beginning, and then from the way we look at great details to implement security the right way. So there's a whole cycle that helps us to implement good security. But that's not the end of the day, and beside this, it's really important for pilots to be quite transparent, because we know that for our customers, the more transparency, the more they'll trust our solutions. And the way everything is crystal clear and Part1 being transparent, we can explain how security works and how data are protected and how communication works. And this level of transparency is really important for trust. So for example, in our application, we chose not to obfuscate anything into our softwares. We don't have any hidden features. So compared to what's been found in other solutions, here we have full transparency, and whenever we can, we use standard protocols and standard file formats. So this can be for security, such as WPA2, or for video communications, as well as file formats such as GUTMA, which is a file format used for flight logs for drone operations. And this use of standard protocols is quite important for security, because then it makes it possible to verify security. So let's imagine that you've got a drone for which the manufacturer provides an encrypted protocol for communication between the remote controller and the drone, but say, don't worry, it's secured, but it's proprietary, so you won't know how it works. So that's not good security, because you can't check it's done the right way. And they could use a few marketing buzzwords, such as say, okay, it's encrypted with AES 256. And if you're not aware of cryptography, you may say, hey, okay, that's good standard and that's a good algorithm. So as far as I understand, I would trust this. But then if you go into details, you can see that the way it's implemented, the way you may have session keys, the way you use block mode of operations into encryption, there's many details for which security could fail. And because it's proprietary, you won't be able to verify it's done the right way. So here for Part1, it's quite important for us to use standard protocols, because first it helps interoperability, but then it also helps all of our clients to verify it's done the right way. So we also have an open SDK, so you can interact with our drone with an open software development kit. This is the secure exchange of information between the drone and other software platforms, SaaS solutions, cloud, and everything. Just 2 words about privacy. It's important to speak about security, but privacy it's also quite important for Part1. And the transparency I just mentioned is quite important for privacy. And so first, we don't collect any data by default. So when a user flies a Part1 drone, no data is shared by default, but still a user can choose whether or not he will store data online. So we only speak about flight data here. And what's important for data processing transparency is that when you look at our privacy policy, it's quite clear why this data might be processed. So for example, concerning flight data, it can be useful for the user to store it on Part1 servers so that he can synchronize data between one device and another device. So for example, between a smartphone, a tablet, and a computer, so that whatever device the user will use, he will access to the flight data about current and previous flights. But this same data is also potentially useful for customer support, and it may be useful for Part1 to enhance products. And at the end of the day, it's important to understand the different purpose for which data can be useful, because then within the organization, this data might be widespread between the server that allows a user to synchronize data, or to the servers that are used by customer support, or to different systems that are used by research and development teams to make products even better. So if you consider this, it might be difficult to make sure that users keep control over all this data, even if it's widespread among different services into the organization. And what we did is that we have a global governance of data, and just by one click into the mobile application, a user can decide if he asks for data deletions, and we have a global scheduler that will give the order to every internal server to erase this specific data. So it's quite important, because it's not just a matter of opt-in or opt-out to receive marketing emails, or even at one point in time to share data. Using this, we have privacy by design, because for every copy, for every piece of information that belongs to the user keeps control and can choose whether or not this data can be deleted or not. So here is basically where you can find it into the app. So that was the first part about what we do in terms of cybersecurity and privacy. But once you've defined cybersecurity and designed it the good way, once you've implemented this, it's also quite important to check it's been done the right way, and you didn't forget anything, and there's no error in the way it's been done. So here we have a global framework which is quite complementary, and we benefit from both internal audits, external audits, and audit by clients. So basically, internal audits are those audits done by Part1 staffs. So basically, that's what I've been doing part of my time, because previously I was a cybersecurity auditor, and I did a lot of penetration testings. So it helps Part1 to see if something was done the wrong way and what we have to enhance. So that's a first step. But then we have complementary steps and especially external assessments. So there might be different ones, but the one we communicated about last year was one audit by Bishop Fox. And the assessment team really go deep into details. First, because the perimeter was wide enough, because there was into this perimeter both the mobile applications that controls the drone, but also the different web services with which the application speaks. And we did both source code assessment as well as penetration testing, just to make sure that we stick to the attacker's point of view. And it's important to mention that there's no complacency here and no strong limitation compared to other competitors that use that kind of audits for marketing purposes. But when you look at the results, they say, okay, there's an audit, but we had quite limited time and quite limited skill sets. And by the way, there was no reverse engineering skills among the team, and that was not the purpose. And when you add all the limitations, you see that basically the audit was kind of useless. But then the conclusion of the audit is, oh, okay, there was lots of limitations, but we found nothing. But it's not relevant here. So what we do at Part1 is that we choose the best audit teams with the best skill sets, and we make sure that they've got everything. They can benefit from our source code. They can look to whatever they want. So they define what is useful and what's the good level of verification. So important to see it allows them to deep dive and to look to great details into our solutions. And because we have more and more clients for which cybersecurity is a key point, those clients are also doing additional audits. So we've benefited from many audits from clients, be that in the defense space or public safety, or even in the industry. So there's many professionals that are more and more aware of cybersecurity and are aware that if they want to operate drones, they have to operate it in a secure manner. So they are doing their own audits, and it's great for us because it allows us to validate every piece of work we've done before and to make sure it's been done the right way. And of course, one big part of the audits was the Blue SUS program. So as you may know, we've got the great chance at Part1 to be among the 5 manufacturers which are selected in the United States for trusted drones that may be used for governmental or any sensitive purpose. So during this process, there was audit teams both on the Defense Innovation Unit side and on the users side that checked for security, both on the software part, but also concerning the supply chain and the different components we selected, and the probabilities that depending on the source of those components, there might be security considerations. So as you may see, checking security is just, it's not only one solution, but doing it the right way is the addition of different steps and the way we do different audits. But then, doing all of this, we wondered what we could do better, and we came to bug bounty. So we'll see precisely why we did that and what's the difference between the audits and bug bounty. So first, we partner with Yes We Hack, which is the first European bug bounty platform. So we chose Yes We Hack for 2 reasons. So first, as far as it's the first European platform, they benefit from the wider number of security researchers or security hunters. So that's quite important because that helps the platform to have the wider skill sets and the more people that look at cybersecurity, the better. The other reason is that as we are a European manufacturer, it was easier for us to organize things with a European partner because concerning drones, it's not just a matter of checking cybersecurity on a website or a web service. It's also important for us to provide drones to security researchers, and we define a mix of public and private bug bounty programs. And for part of the private bug bounty programs, we use that to test future products, which means that we select a few security researchers that are among those that are the more skilled on the platform, and also those that we trust, because then we'll give them products that are not already on the market. So we have to make sure that we trust those security researchers. And then they look at potential security vulnerabilities before the product is out, which of course benefits to our clients, because even before the solutions are on the market, we make sure that they've got the right level of security, and that nothing was forgotten or any error in the way we implement things. So that to me, that helps us to be even more transparent and to give always more assurance to our consumer, so that they can make sure that when we say we've got trusted drones and cyber secured drones, it's not just words, it's based on facts. So one of the most important thing is the difference from audit and bug bounty, and we can see here that each solutions has benefits and drawbacks. So, for example, the main difference between audits and bug bounty is the perimeter and the limitation in time or in versions that you may have for audits. So if, of course, a drone would evolve over time, and all the time we make better software and we implement new features into the drone. So even for the same drone, the software may evolve over time. So when we do an audit, we know if there's potential vulnerabilities on this version at this precise time. But the main difference with bug bounty is that you can cover a wider perimeter and you can have continuous testing, because it's not based on a specific time frame, but you can have it all over the year. And if someone finds something, maybe it was an old bug, but it may be also something what was introduced during development on a brand new feature, and then it's quite useful to benefit from the expertise of security researchers that can look at modifications and do that in a continuous way. So for me, that's the main reason for which we decided to go to bug bounty compared to audits. It helps Parrot to have security checking, not just on defined steps, but all the time. Concerning the perimeter, we also saw that we focused on actual drones or future model of drones and the way they are secured, but seeing how security researchers participating to bug bounty works, they work just the way an attacker would do, and they also look at older solutions. So, for example, Parrot has been doing drones for more than 10 years, and we may have cloud services to retrieve logs from older drones at a time that cybersecurity was not at the same level with the same needs. And most of the times at that time, Parrot was mostly doing toys and not drones for professionals. So having this wider perimeter, we can benefit from better security for all products, not just those from today, but also those that were sold something like 5 years ago and didn't have the same level of security compared to those we provide today. So the way that we base this analysis on a wide range of researchers that have better skill sets, because the number here is quite important. When you think about cybersecurity, it's not just one field of application. Cybersecurity is quite wide. And when you think about cybersecurity and the skill set needed for cybersecurity, you can see that some security professionals are really good at understanding the network and the way that network protocols can be misused or can be protected. You can see that other security experts really do know how to secure a mobile application or a web service. And you'll see that other security professionals are really good at securing an embedded system or attacking an embedded systems. And there's a wide range of skill sets. And at the end of the day, there's no way that one or two auditors can have all the skills that may be needed for a wide and global view on cybersecurity. And all the times you may have 1, 2, or even 5 or 10 auditors, you'll be always limited to those skills they have at the time of the audit. The great benefit with Bug Bounty is that you benefit from all the skills from hundreds or thousands of security researchers, and all of them is really good at something, but the fact that we benefit from the sum of all of those skill sets make it a good complementary view. So that's basically the main difference between audit and Bug Bounty in favor of Bug Bounty. You also have to be aware of some of the drawbacks, and for example, it's most of the time easier to go into details with auditors compared to Bug Bounty. And for example, what we did with Bishop Fox, we shared source code. We spent weeks and weeks, if not months, to exchange with them so that they first have a global view and then go into details of one thing and another. And that needs a lot of work, and that needs a lot of exchanges so that they can understand everything of what we do, the way we do it, and to check we do it the right way. If we compare to Bug Bounty, most of security researchers that participate to Bug Bounty look at easier solutions, and of course they stick to the way that an attacker would proceed, but sometimes with more superficial view. So that's one of the drawbacks. And another drawback is that with Bug Bounty, you have to do more triage, which means that you've got maybe a few reports. And among those reports, let's say over 10 reports, there's 1 or 2 that are really important, and you may have something to do better. But for others, you may have report for hypothetic vulnerabilities that may have absolutely no impact on real confidentiality or integrity or availability of information. So it may be hard for a security researcher participating to Bug Bounty to understand the drone market, to understand what security needs we have, and it's easier to have that kind of exchanges with security auditors. So just to sum up, Bug Bounty is not an all-in-one solution. it's really complementary, and that's why I wanted to speak to you about the security by design, the different steps, and the way we implement security, the way we check it. And at the end of the day, bug bounty is relevant just because we had the previous steps and we did security by design, and then we first checked with audits. If we did not do that, I guess we would have tens and tens of reports within the bug bounty, and that would be really hard to manage. But here, because we did all those previous steps, we have something that is complementary and just helps us to make sure that we didn't forget anything, and there's no an old function that may have a default or anything like that. So it's quite important to have both and not just bug bounty. So it's basically it, and I guess we may have questions now.
Yes, I'm joining you now. So thank you very much for that, Victor. Appreciate the presentation.
Welcome.
Okay, so we do have quite a few about the bug bounty, obviously, and I'll try to get through them. But I think the very first one, without just thinking about the bug bounty side, was what is the drone security job demand like currently?
Not sure to get your question precisely.
Okay, so do you think the demand for security within drones is increasing to the point of people getting jobs in drone security?
Okay. First, I think that on the client side, there's more and more clients that get aware that security is a prerequisite, and they need cybersecurity to operate drones. And I think it's a big change because I'd say 3 or 4 years ago, most people wouldn't even ask for security, and they wouldn't have the idea to say, I need a secure drone. And nowadays, we see that security makes a real difference because you have devices that can capture really sensitive data and can be used for sensitive operation, be that for public safety, defense, or even inspection or mapping on critical infrastructures or things like that. And when you do that, you do need cybersecurity. It's not just an option. If you don't have cybersecurity, you can't conduct your operations. So as far as you or clients, users really do need cybersecurity, I think it will be a broader topic today and in the future. And of course, that's a priority for Parrot, but that's also why I said that it's continuous improvement, because for cybersecurity, you can just get asleep and say, okay, I did the job and now that's done. I won't do anything more. Attackers will always have new ideas. There will always be vulnerabilities in software components. If that's not my components, it might be a component with which drone interact and with which drone can exchange data. And drones will be used in a more and more autonomous way, and you'll have more and more connectivity on drones and more ingestion of data captured by drones sent to other softwares. And the more you go to this open world, and the more drones will be used for professional or security uses, and the more you need cybersecurity. So I'm quite sure that in the next months and years, there will always be more and more a job for cybersecurity in drones.
Mm-hmm. Okay, well summarized. Okay. And we'll continue with some of the bug bounty questions. So one of them says, is the bug bounty you're conducting only oriented to software, or do you also do hardware security? And I think this is probably the public-private part of it.
Yeah. Actually, it's both, and the main difference between public and private is that within the private bug bounty, it's easier to organize the way we can provide a drone to security researcher compared to public, which is not possible at all. So public is good for web services, mobile applications that are available right away. It can also be done on part of the security features that can be tested with a simulator. And that's why also I mentioned that at Parrot, we have this transparent way of doing things, and we provide a lot of tools to understand the drone and to simulate the drone, and it's really useful. Not just for cybersecurity, of course, but for everything you may do with the drone. And doing this simulator, it emulates a drone's firmware completely. So any security researcher, without buying a drone, can also test the drone, even in a public bug bounty program. But then, the more you go into details concerning the hardware, and the more useful the private programs of our bug bounty will be, and it's especially the case concerning the secure element I spoke about just before, because that's a security component that can be emulated or nothing like that. And of course, you need the electronic board and the hardware to test that. So really, we do both. But we can do both at the same level, because concerning the hardware, we have to select a few security researchers, and we can't make that public, of course.
Okay, makes sense. And look, we might have some more short answer questions that are specific to the bug bounty as well. The one is the private program open to people outside of Europe?
Yes, and for example, yesterday I answered to a security researcher that is from India, so it's quite open. So the way it works is that for the moment we have mostly private programs, even for actual products, and those private programs helps us to improve the process between the security the bug bounty platform and Parrot internal staff, and to make sure that it's the more fluid and everything goes well. So in a few weeks, we'll have full public bug bounty programs concerning this perimeter. And in parallel, we'll open more private programs with that are focused on future products, but only on private programs.
Mm-hmm. Okay.
But on both sides, we can have a mix of European and worldwide researchers. And yes, React is the first European platform, but of course, there's a lot of Americans, there's a lot of Asians or Africans researchers. So there's no problem at all to have all those products. And we chose a European platform just because it's easier for us with this platform to organize the way we ship products to some researchers. So that was just more convenient, but it's absolutely not a limit concerning the kind of people that can go to the platform and enroll to those platforms. So if you're a security researcher, just enroll to Yes React, and you can even speak with me in private and say you'd like to join a private program, and we'll see what we can do, but it's possible.
Okay, brilliant. And I think we'll go on to one last kind of dual question here before we take a break, and thank you. And that is, have you seen any surprising submissions yet? And what is the price ranges for payouts that Parrot has offered?
Actually, the price range depends on the perimeter because we have different programs on different perimeters, but it can go from a few hundreds for low impact vulnerabilities to a few thousands for higher impact. and you'll know more about the scale of rewards once we have public programs, which should be in a few weeks. And as of today, I haven't had that much reports, and a few of them was quite interesting. So it helped us improve our all infrastructures and softwares. So for the moment, it was quite useful to have this bug bounty program, even if there's no catastrophic discovery for the moment.
Yeah, well, that's always good news. So brilliant. Victor, thank you for coming on again. Thank you for your presentation. And we enjoy the transparency that you're able to give and the focus that you have as a company on drone security. So thank you very much. And I hope everyone will join me in applauding Victor for his talk. So thank you.
You're welcome. And maybe see you at next GDSN.
Exactly, that's right. Maybe 3 times lucky. So, okay, thank you, everyone. And we will be back in roughly 4 minutes for our talk with Kim James. So look forward to seeing you then. All right, we are about to resume, so we'll be coming up very soon. And hi, Kim, how are you doing?
Hi, Mike. Very good to see you. Long time no
Likewise.
see.
I know, and we were very lucky to have you last time, sharing some action pics of the field and the operations you were doing, which we loved. And again, we're humbled to have you return again, especially in the circumstance. So thank you very much. And yeah, we want to welcome you from South Africa, and just double check your slides are up and that they're ready to be shared. So let's have a look at that. Okay.
Right, how's
Brilliant.
that looking?
Yes, I can see them ready and should be on the screen very soon.
Mike, just let me know.
Yeah, just go up the top and click display settings and switch display, and that should be totally fine. Yep, that's the top one, sorry.
Are we good there?
Almost, go back, sorry. There we go, that's perfect. So I'm gonna let you take it off from here, but thank you very much, and good luck with the presentation.
Thanks so much, Mike. Thanks for seeing you guys again. I can't believe it's been a year. So unlike the presenters that you have on and the theme of your presentations around being anti-drone and counter-drone, we, of course, here in South Africa and our company called Drone Guards, work with drones for good, and we use drones to secure our people and high-value assets. And specifically today, what I wanted to talk about is how we are effectively integrating drone technology into existing operations to fight crime. We have a very high crime rate in South Africa, and we're specifically integrating this into law enforcement as well as private security. So just very, very briefly about me, I'm the director of our company called Aerial Works, which is a CAA registered drone operator, and our security arm, Drone Guards. I'm a safety and security post holder for our company. I sit on the board of COASA, and I also chair the new applications chamber for our Drone Council in South Africa, which was formed last year. And I've been fortunate enough to co-author a couple of books called Drone Professional 1 and 2. As you can see on this photo on the top left, we're doing quite a lot of work with the South African Police Service here. And so oftentimes when I am on site doing some safety work and some risk assessment work on sites, I get the pleasure to hang out with our local police. Very briefly, for those that weren't in the session last year, our drone operations in South Africa are regulated by the South African Civil Aviation Authority. And as much as people quibble about our very strict regulations here, it is actually what is translated down through ICAO and our Acts of Parliament into what we have to operate against in South Africa. Again, very briefly, anytime we operate commercially in South Africa using a drone, we have to have licensed personnel, we have to be licensed as a company, and we have to have our aircraft registered as well as insured for third-party liability. For context, we, at this point in time, I still think probably globally, but specifically in South Africa, we, in the context of security, are able to operate one drone and buy one pilot. Of course, our current security solutions in a very simplified manner are very much, a guard with a torch. And the future for us most certainly holds potentially sitting in a control room somewhere in another city, even controlling multiple drones. We're hoping in the near future to be able to have one pilot, many drones, particularly in the context of potentially swarming. But right now we need one pilot, one drone, and that pilot needs to be on site and have control of that drone, even if we're managing automated missions. So what does law enforcement look like in South Africa? And that is something that we're very interested in. We have our local, what we call metro police, and they're normally the traffic police. We have a private investigation arm called the Hawks, and we also have our police service. And of course, we have our private security. Now, why are we talking, law enforcement integration or drones integration into law enforcement in South Africa? Well, our crime rate in South Africa is massive. We do still take up 4 of the top 10 spots in the most dangerous cities in the world from a crime and murder rate perspective. Our unemployment teeters around 30%. And this slide here is quite basic, but it tells a massive story. And this is really around the fact that our police service in South Africa is woefully under-resourced. Total employees in the police service sits at about 180,000. In contrast to about 2.5 million registered private security officers in South Africa, of which we think 5.5 million are employed. And we have about 10,000 registered private security businesses in South Africa, or security companies. I think the global best practice stats for police per citizen is about 220, and we are about 1 police officer to 310 police officers, and to 310 citizens. And it's a massive problem with as much crime as there is. The private security industry in South Africa is regulated by something called the Private Security Industry Regulator. And of course, you can see that private security outnumbers our police force. So I want to give you 2 use cases today of where we are using drones for good to curb crime. One is a practical example of securing a CBD. Johannesburg CBD is rife with crime, active hit, as well as just random murders in the middle of the street during daylight, robberies, crime syndicates, etc. And so basically, this started a couple of years ago with the closure of a major highway that connects kind of areas coming into the CBD. And this is just a collection of news articles during that time where this major motorway had to be closed because of major renovations. It was actually starting to show some stress damage, etc. And so they had to close this motorway. And with the result that people who actually worked in the city, and there are major banks and huge corporations that have decided to stay in the city, they own those buildings, despite the high crime, needed to look after their employees because their employees were being hijacked and robbed while they were sitting in these major traffic jams. So basically the private sector got together and said they need to do something about this crime. There wasn't enough of a police force to actually ensure that they could help the motorists and the pedestrians coming into town. And so basically, we were called in at the same time as a Forum for Integrated Risk Mitigation Group was formed, is firm. And this was basically the private sector coming together, all the individual companies, banks, etc. And they said, right, how can we help create safe corridors for our employees? And part of that solution was, as you can see up the top right-hand side, every company that had their own security guards actually trained them in the same way. They wear body cams, they wear they have two-way radios. At a later stage, they went onto the Zello platform because they actually, the cops, the police didn't have enough budget for radios to be able to communicate with the private police force. And they all wear the same high-vis jackets. And then, of course, the drone security would have been integrated into that. And so the whole idea was to have zones that would create a kind of a permanent aerial view of that whole city area. The whole idea, and I won't go through everything, but the whole idea is that proactive operations in conjunction with the ground forces would have then created safe corridors, as I already said. That drone footage streamed into control rooms. The visible policing, also from an aerial perspective, also monitored security teams, and that's what they wanted. Real-time monitoring of randomized missions. And then, of course, there were ground security measures, but this was a layer on top of that. There are hotspots that are focused on, and this is all about preventing and preempting. Of course, from an incident response perspective, you can see things unfolding in front of you, and we actually did some work for a major implosion that happened of a major building that they were going to demolish. And so you can literally see it's an eye in the sky, which is a view that the security forces on the ground never had before. The idea is really not to interfere if you don't have to, and so the cease and desist approach was really the chosen method, where speakers can be used to communicate with pre-recorded messages, etc. In the city center, where, of course, specifically with financial services organizations, there's always that threat of terrorist activity. That mass evacuation could actually be aided with drones, where safe corridors again can be marked, and real-time monitoring of those emergency situations, and then tracking and monitoring of vehicles, suspects, etc. Post-incident activity with this drone technology is really around footage that's permissible in court. It's geotagged, it's time-stamped, it's stored as appropriate. We actually have a new Privacy and Data Protection Act that's been in for a while, but it's now active from May. And so storing of this data is very important. And then, of course, for training, to understand what the MO of the syndicates is, etc. And then we've started this, but really around machine learning. So, pattern identification, and we really want to be removing the human intervention over, over incident response, etc. So this is kind of what the city center, part of the city center, looks like. This is one of the operations that we were involved in to actually secure a perimeter there. And this is where we've already for over 2 years been working with the local public safety agencies and law enforcement. And this was that one event that we assisted with. So evacuation and security surveillance, that I'm not going to play this video in the interest of time, but this is kind of the eye in the sky view that the security teams never had before. And so, with tall buildings and narrow streets, and a lot of them in the city center being one ways, pursuing someone or seeing something but not being able to get there is always a pretty big challenge. So fast forward through COVID, because that project was actually put on hold because of funding and COVID lockdown and what have you. These images are actually from a simulation exercise we did a few weeks ago, again with the SAPs. This guy on the top left-hand side is Colonel Garuda, who is in charge of one of the police precincts, and our client. And basically, the idea there was to kickstart the approval process of being active in that firm security operation, specifically around tracking vehicles that have been picked up on their license plate recognition software and their cameras that are in place. So I'm just going to play this. There's no sound to this, but just as an example of essentially what it is that we're going to be doing in the city center. So just a really benign flight. And what we wanted to do here is demonstrate to the client, and specifically the cops, the police teams, of the zoom capability of the actual drone that we use to demonstrate this. And the maneuverability. This specific exercise was done with a multi-rotor, and the reason for that is because you can see how it's flying between these buildings. It's the latest technology, so it has very little interference from the buildings, etc. And this specific footage is being streamed into one of the control rooms, which is kind of underground in the building that we were operating of. So the idea here, and you'll see it in a second, is that it can keep an overview of vehicles approaching a traffic light system, and this is often where the hijackings take place, when stationary vehicles are exposed to someone who's hiding, and concealed, and then comes out with the firearm or what have you. In a second, it will switch over to the actual simulation exercise where there was a vehicle that was pointed out that we now needed to pursue, which is coming up now. And the technology, I mean, it's not amazing technology that none of you are aware of, but you'll see now the actual camera is acquiring this target, and it's the second vehicle from the right, which has now been identified as the target to pursue. And you will see in a second, it's actually locking onto that target. And the challenge that the police and the security forces have in the city center at this very spot is that as soon as this number plate recognition system picks up a number plate of a vehicle that's been involved in a crime previously, or is kind of under a wanted mark, they lose it behind buildings. And you can see here, this camera continues to focus on it as it's disappearing behind the building. And here there are two ways for the vehicle to disappear. One is left away, and one is right underneath this bridge and then onto the motorway. And by the time the police or the security forces can actually get to that spot, they've lost them. And so the idea is, with the drone, they can then already know where they're needing to deploy their resources to. This was just a picture or two pictures of the footage being streamed live into the control room, and you can see there on the left picture on the top right hand side, that's actually the first person view from the and with the controller overlay, which is really locking onto that vehicle. And so, we didn't fly over the highway because we didn't have permission on that day to do that through the roads agency. But the idea is, once the permissions are in place, to be able to do that. So it's really giving information through to the individuals on the ground that need to be pursuing. I presented this recently somewhere, and people were just blown away. This is a very basic tool, and I don't know whether you're all familiar with that, but Zello is an app. It mimics a walkie-talkie or two-way radio. And as you can see on the left-hand side here, the Joburg Central police station is actually using this. And there are like 25 people on there, including police officers, including we are on there when we're there doing drone ops. We are called Eagle One now. And there are also citizens on there who are literally, feeding information. And it just by using this has cut costs, and it's also just increased efficiency of communication, where for information sharing, heads up by citizens, they've actually cut the crime in that specific area for that precinct by 50%. Now, it's still very high, but just by doing these few things, by increasing communication, etc., it's already helped. Now, the challenge we have in South Africa, even if like this was an operation we did recently from a rooftop where there's zero risk to anybody while you're operating, you're of course going to be flying over people, property, and public roads. And so this is a very basic kind of depiction of the permissions that we need to obtain in order to fly in an area like the city of Joburg. So first of all, police service has to know that we're flying there and has to give permission. The properties we're flying over in this very instance are privately owned, or at least owned by the organization. So Absa Bank, Anglo American, First National Bank, etc. And then, of course, the public roads. So Joburg Road Agency, as well as the police. And of course, in South Africa, the accountability that people are willing to take to give these permissions is quite slim. And so, for the permanent operations to actually kick into place, there is still quite a lot of work to do to be able to do that. And it's all from a risk perspective because we're flying over people, property, and public roads. And so we continue to work with the Cooperative Governance Council. We continue to work with the police and the firm to get this implemented into a permanent solution. And really, it's around getting those public agencies and the law enforcement agencies on board. But it's been massively successful, and the people on the ground just can't wait for this to actually kick into place on a permanent basis. Okay, and so this is, and Mike, I'm sure you'll stop me when my time is up, but I'm going to plow through this. This is the second use case, and this is again where we have integrated drone technology into a private nature reserve where they have in-house security. The community around these properties that are massive and very kind of far apart and at quite high risk, although not as high risk as in the Joburg city center, they have almost no support from the local police force because of a lack of resources. They just don't have the vehicles, they don't have the manpower to actually help out in these situations when crime happens. The crime profile of this kind of scenario is a little bit lower. It's really petty crime, but it's a private nature reserve that has about 1,200 beds in high value and kind of 5-star private lodges. And their reviews started going down because their crime rate started getting quite high. So this is where visible policing, I'm not going to play this whole video, but essentially, again, we started here and we still have a permanent drone team on site. We started doing what we called gate awareness operations. So where the contractors come in during the day to work on site, they're cleaners, they're maintenance people. This is where they think the inside jobs and information gets leaked to people. And this was actually literally on the first gate operation. This vehicle that's standing, that you can see coming up now that the drone is focusing on, didn't actually pull up to the gates, which is the normal process. and they kind of stood outside. So the normal process is that the vehicle would drive up, the individuals climb out, they go through, at this point in time, their COVID-19 tests, or at least their protocols to sign in and get their temperature and checked and what have you, and then the vehicle checks in. But these guys literally, and by the way, nothing happened here, nothing untoward happened, but the security guards at the gate called this out as suspicious. And so they had actually noticed the drone and were looking up at it. But they gave this vehicle eventually a thorough kind of search, because they kind of thought that they were bringing something in, or at least maybe the driver was. So this very, very quickly spread as a kind of message throughout this nature reserves, contractors and what have you, that there are eyes in the sky. So let's not even mess. And literally, they used to have crime every weekend. And from the implementation, within like the first 9 weeks, there were a couple of incidents where we found people on site, but it cut the crime right down because of the presence of the drone. This is where we're actually training local security staff on how to work with the drone team, because it's about identifying something, and when the drone team identifies something, to through radio communication vector these individuals in on a very dark, desolate site. We also did some kind of covert operations where the drone team parked elsewhere and then flew over areas where they were building new lodges, etc. And this is, again, training the local team. These were some simulation exercises. And it just goes to show that, you can see from these faces, even the first night when the thermal camera was demonstrated to them, and I'm just going to play kind of a minute of this, but this is so dark that those security teams, have their tiny little torches, but you cannot see your hand in front of your face. And all of a sudden, with the thermal camera and the specs that we have on that thermal camera, they could literally see individuals walking. And it just proved, kind of eye-opening, and it's just a completely new world for them. And this is now the kind of result of us engaging. You can see on the bottom left, the local police, kind of heads. There's a brigadier sitting with the white shirt kind of at the bottom of the screen. And this is really a town hall with community protection forum individuals, the actual GM of the nature reserve, all the neighbors. So we've engaged the neighbors as well to get their permission for us to fly over their land if there is a pursuit in play, etc. And so really engaging the community as well as engaging the police force, where they know that, it's an additional layer and it's helping them because they really don't have the resources, as I already said a number of times. So the outcomes here are, the neighboring communities have been engaged. We've reduced the crime. It's a permanent drone program, so they fly every weekend when the hotspots, or at least when the witching hours are. And we've been invited a number of times now to work with the local police to actually help them when they do their visible policing on the main roads, etc. We're also implementing a neighbor model where the neighboring farms and sites are actually working together now with a shared drone, because the cost is still quite high in South Africa. So basically, what are we doing in South Africa with drone technology from a drones for good perspective? And it's really around staying ahead of the criminal. The criminals don't care about our regulations. The criminals don't care about safety. The time delay of sometimes getting to places from a permission perspective. There are still technology limitations from a cost perspective, from a human perspective, and also, the stakeholders that need to be engaged are oftentimes expecting, the drones to be armed, expecting the drones to be able to, display a, 24-hour hang time for very little cost and no regulation. So, we do still have limitations, and oftentimes in a engagement of local law enforcement agency and security perspective, there's the question of who pays for this, because the whole reason for us integrating from a private sector perspective with law enforcement is because law enforcement in South Africa just isn't resourced and doesn't have the money. So it ends up being private sector paying for this. But if we can together address the crime in our country, then of course, we do that with pleasure. And then of course, we talk about having an integrated workforce, and it's the most effective way of, and we say fight crime, but it's really, and we've seen examples of this, it's really around moving crime, because it's not eradicating crime. It's really around potentially moving crime to a less heated area, and they go to the next soft target. However, having that air force is really empowering those local security and law enforcement agencies. And Mike, that is my story. I'm very happy to answer questions.
Yeah, absolutely. Kim, or should I call you Eagle One, I guess. You're a terrific storyteller, and it's really interesting because, as you said, drone security is not just about securing them or countering them, but using them for these security purposes.
Yes.
And so I really appreciate you sharing those kind of on-the-field vision and photographs of your operations.
Thank you. Thanks for having me. Are there any questions?
There are, so I was going to go through these now. So the one question was in the chase locking scene, if the BVLOS was dynamic and goes into different areas you were not originally allowed to go into, how do you get that dynamic or live BVLOS permission?
Yeah, you don't. You don't. Yeah. So look, you can't. It would be illegal then. So, and that is the problem we still have in this country, because essentially the client expectation is that you're going to pursue that vehicle or that individual until capture, right? And if unfortunately the ground forces cannot reach that, that target by the time we've reached another motorway or, another built up area where those permissions run out, we can't continue. So the caveat to that is if the police force who work under different regulations, so if they own the drone and they operate the drone in permanent operations, they override the CAA in that aspect.
Oh, wow.
But so they can go anywhere, right? So, even with their helicopters, right, we've been operating, and it wasn't a security operation. We were operating, doing a land survey. And this helicopter basically came straight into our area of operation. And, the PIC got on the radio and before we'd recognized it was a SAPS helicopter, the PIC kind of said, drone operation, get out the way. And expletive, basically, because it was a SAPS helicopter. And they operate, and they can operate at any, obviously safe, but at any altitude. So they can operate wherever they need to, if it was their drone and if they were operating it. But since we're operating it, even though it's under SAP's permission, we would still have to operate within the boundaries of where our permissions are. And that is the challenge we have in South Africa still with, I mean, it all comes down to safety, right? So now we might be operating in a uncontrolled airspace. And now we're pursuing, and now we're heading into controlled airspace, and we don't have that permission. Unless we know that, you know, if we were to really be forward thinking and actually get permanent permissions for, you know, kilometers and kilometers around that. So of course there's a solution for that, but practically you never know where these targets are going to head to, right?
Yeah, wow. Okay. And in that same vision, you know, you mentioned Sabsa Bank and some of the banks there. If they don't own the airspace above their property or their buildings, why do you have to get permission for them?
Because we are flying over it. So it's all about landowner permission, and it's all about privacy and yeah. So it isn't their airspace, but the airspace over them would not override, but be in addition. So the permissions we would need, that's Special Rules West, just as an example. So we would broadcast by that frequency. If that was controlled airspace, we would have permission to fly there anyway via a KMU reference. But any property you fly over, road or property, whether it's privately owned or government owned, that's the permission you would have to get.
Yeah, wow. Okay.
Yeah.
And another question we had on that same, I guess, film section was which drone make and model and potential fit outs were you using for that video you showed? I assume it's probably the first one with the zoom in.
Yeah. So that specific one is DJI M300 with an H20T camera. Pretty standard. Okay. Yeah.
Nice.
Yeah. Very nice piece of kit for that.
Out of interest, Kim, how large is your fleet? I guess if you've got some of these semi or permanent installations in different places, and is it ever purchased or owned by the client, or is it always yours and you know it's your fleet that is being kind of rented out as that service?
Yeah. So the size of our fleet is confidential, but the combination of whether the client owns the asset or whether we deliver the service, we have both. So it's probably coming up to an equal spread of both. Yeah.
Okay.
So it's more cost effective for the client to own the asset. So we kind of have a model where that works quite well, as opposed to the client, you know, bringing us in for a full service.
Okay, brilliant. And I've got another one here which says, do you see any drone in a box security guards replacing any of the semi-manual operations that you currently do?
Yes, of course, that's the future, right? The reason why our technology now is still so, or at least the service is still so expensive, because it needs that human intervention 100% of the time. Even though we can do automated missions, you still need to be on site to be able to take control if something goes wrong. So drone in a box is an interesting one, because I probably have 4 or 5 calls on that in a week, where people are just saying, I just want that drone in a box thing, or that drone on the roof thing, or that, whatever. So that would be fully automated and, fully autonomous. And that is not regulated in South Africa yet. So I see there are a couple of security companies that are kind of quoting their clients on these things, or saying they're going to quote, and then they try and find the actual solution, and they can't yet. So I know it exists. There are military applications that are trying this already, or testing it already, but I have not seen it in South Africa. But it has to be the future, right? It has to be where something is just permanently charged by, solar. We've got sunshine pretty much all round the year, same as you guys, I guess, Mike. depending on where you are. But yeah, it's there's still a lot of considerations, you know, how integrated that technology is with your fence triggers and your ground control and, you know, your machine learning, because clearly a drone is only going to be as useful as what the resulting action is going to be from what it sees, right? So, but in short, the answer is yes, I do see it, but it's not here yet from a regulation and actual, you know, accessible technology yet.
Yeah, okay, brilliant. And there's something here that mentions on your permanent aerial view of the city, were any of these tethered or based on, again, drone in a boxes? And the second question is, were any of them threatened by those you were surveilling or noticed?
Okay, good question. So no, we've never used a tethered drone system. I kind of have personally, and in our company, we've never seen the use for it because the cost of it and the flexibility of it just doesn't make sense. So number one, none of what you saw was from a tethered drone. Yeah, so I think maybe the question is around that one image from the top. That's just an image we took from the actual drone. And what was the second part of the question? Oh, whether our drones were threatened. Is that the question, Mike?
Yeah. Were any of your drones ever threatened or noticed by those you were surveilling?
Yeah, so we have not had any threats to our drones yet.
Nice.
But we do know of stories, and it was not our teams, it was actually another company who had actually resulted, their drone surveillance resulted in an arrest of an individual. And when they kind of, you know, unpacked his backpack to see what he was carrying in it, there was this like a homemade slingshot. And you guys are all going to be laughing at this, but, you know, they asked him, what's the slingshot for? And he's like, for the drone. So, you know, it's very rudimentary. I have also heard of a drone being shot at, and these are like where your high risk areas like mines that are being protected, where, you know, the value of what's being protected is very high. And so the criminals will do whatever they need to do to get in. I mean, the security guards on the ground get, you know, shot at, and the guys have hand grenades and stuff. But I've never heard of a drone actually being ruined, like as in taken out physically by, you know, a ground threat, or what you guys would be talking about, you know, in the context of some form of, you know, cyber threat. So no is the answer. And I hope, and I know I said this last time, Mike, but I hope it stays that way.
I know. Well, it's been a year, so that's obviously a good step in the right direction, right? So
yeah. Absolutely. Yeah.
Great. So this last one's from me because you know, when I'm thinking about your role and the amount of things that you touch on in terms of the regulatory compliance side, my question to you is, do you ever just kind of throw your hands up and say the regulations and the compliance side make this too hard? Or do you see the whole part of this job as half of it is being compliant and half of it is using innovative technology?
That is such a good question. So if our MD, who's a serial entrepreneur, would be sitting here, he'd go like, yes, way too hard. I want to throw up hands. Okay, so look, the regulations are hectic. As you quite rightly heard, you know, we are bound by where we can get permission to fly. A lot of times the municipalities are not responsive. You know, it really does hinder. Now, from my perspective of a safety officer in our company, I would say that most of that makes complete sense from a safety perspective. Because if that didn't exist, then the replacement for that would be the categorization model, drone ID, UTM, and everything we don't yet have. So lifting any of what we have now or reducing the cumbersome nature of what we do needs to be replaced with something. And dare I say it, I mean, in our country, we're pretty lawless. We just kind of people just don't adhere to rules. And this is aviation, right? So I would say it's a really fine line, Mike, between the frustration of being able to operate and the speed at which we can operate. So we have a whole fleet of aircraft waiting to so we've gotten to like the last hurdle of getting them registered, and then now need to get on our op spec, and now we're just waiting. And until that happens, you can't operate. So now it's like they're just standing there, and it's expensive kit. And you're like, ah. So a lot of it's process and how quickly it can happen. So yeah, I think there's a really fine line between, I think the regulations are good because it drives safety and the right behavior. And it's also something we have to do until it changes. And then, seeing how it does actually hinder the development, of using our technology to do cool stuff, So I hope I answered that.
Yeah, you did. You did, and I share it as a fellow, I guess, person who deals with both on the regulatory side as well as trying to enhance and enrich with new innovative technology. It's definitely a battle you wage, but at the same time, it can have its great benefits. So, absolutely, I think you're trailblazing a lot of this, things in South Africa, and really appreciated having you on, Kim. Appreciate the stories from the field, and yeah, thanks again. I want to just ask everyone to thank you for coming on.
Thank you. Thanks so much. Good to see you.
My pleasure. All right, everyone, that was Kim James and Masumi. You can leave me on. I'll just have a few quick words before we wrap up for the end of the day. So the key things you need to know. So we'll be starting tomorrow a little bit later, as I said. We've got 4 presentations lined up, and I'm really looking forward to some of them. But one of the things we just ask is that feedback form. We will put it both in the YouTube description as well as some of the comments. But appreciate you joining us for this first day, and look forward to having you tomorrow. So thank you again to all the speakers. Thank you to the guests for coming in and joining us, and we look forward to tomorrow. So thank you, goodbye, and good night.